Good evening, good evening, good evening, everybody. I hope I'm clearly visible and audible. So, good evening, my dearest JEE warriors. How are you? How is everybody doing? Let me just refresh that comment screen so that I can see and read your comments so that we can make this session quite interactive. So just mention in the comment section, beta, whether I am clearly visible and audible, everyone. Huh. Now finally, beta, to the to the discussion that we have started in YouTube, that is definitely free of cost. We have started catering all the chapters of physics, chemistry, and mathematics as per JEE. And when I say JEE, I specifically mean JEE mains because beta obviously JEE advanced, yes. So good evening beta. TG, okay, T Gokul. So good evening T Gokul. Now the planning that we have made, and with that execution I'm here, that we'll be taking NCERT as our reference. Now this definitely does not mean that we are studying for board level questions, obviously no. We are targeting NCERT and we are exploring all the concepts of NCERT and moving beyond those concepts, but yes, by keeping NCERT as our reference. If you talk of the chapter which I'm going to start for chemistry today, that is electrochemistry, a very beautiful chapter, for JEE mains also, for JEE advanced also. JEE advanced obviously ask student to think high level conceptual side of any topic, not one but all the topic. They ask students to be very disciplined and learn those logic conceptually, and JEE mains, what they do is they extract the questions of JEE advanced, and therefore for this particular chapter of electrochemistry I would rather say JEE advanced, whatever they has asked, JEE mains have started absorbing that. Therefore for this chapter you always have to move beyond NCERT. So what we will do for this particular chapter beta, I will be breaking this chapter into two parts, if at all we will be getting time, because I didn't want to extend to make this session to make this live long, because I want you to go back and practice. Sir, where to practice? Definitely the concepts that I'll be dealing with you. Go back and practice those PYQs. You can also download these lecture notes from where, just after the session is done, you will be getting all these lecture notes in PWJE English WhatsApp channel. The link to the WhatsApp channel will be there in the description section of this video and in the description and the bio section of the channel of PWJ English channel also. So please make sure after the live is done, you go and download these notes and practice, because I will be giving some practice questions also. But yes, we'll be making and dividing this chapter in two halves. First half I'm dealing over here and second half I'll be dealing in the next session. Or else if we get through it, we will try to finish it in the same session, but I guess that will be extending the session beyond limits. Why? Because first of all you need to target, you need to practice these set of concepts, and then only you should move forward. So yes, good evening, hello beta, hello Sandhya, hello beta. Sir, can 11th class can listen to this? Beta, class 11th, technically yes you can, but yes, you can, because if you have a general basic understanding, then you can, or else beta, this is a good topic. This whole chapter is a good chapter, but yes, because I will also be dealing with the at most basics, so don't worry. Yes, you can definitely, if you belong to class 11, still this will be quite useful for you. Sir, how long will this lecture go? Avinash, as I was already communicating, that I will be making it 3 hours, maybe 3.5 hours. That's it. Because I want whatever concepts we'll be having, we'll just relax and keep these concepts from the basic. We'll pick them from the basic and make them till the level of advance. Okay. So good evening, Tasmeem. I hope now everybody is super ready with their pen and copy. Make sure you are writing whatever, you are making notes of whatever I'm dealing over here. Cool. So let's start with the discussion of electrochemistry. Chalo. I hope beta my voice and the video is clearly visible and audible to everybody. Just give a confirmation on that front whether I'm completely visible and audible. Yes, we have more participants. Sir, can I see it for the first time? Definitely you can, beta, because as I said, I will be picking it from at most basic. Sir, will you tell atomic structure? Yes, Sandhya, I will definitely, but obviously after this, because first we'll be dealing with the class 12th syllabus and then we'll be brushing those class 11th logics. है ना? So good evening, Harsha. Good evening, Harsha. Very good evening. Tasmeem is asking, सर सब बोल रहे हैं कि तुम जेई नहीं कर सकती क्योंकि क्लास 12 60% आया है. Beta, yes, if your class 12 marks are 60%, then yes, definitely for JEE Advanced. Even if you score well in JEE Advanced, but no, you will not be getting a seat in IIT because they have a criteria that you should score. You should score above 75% or at least be among the top 75 percentilers of your board. So yes, they are right in that sense, but yes, you can definitely aim for NITs. This was my first class, sir. So Harsha, why was this is your first class? This is not a past tense. We are just going to start the session. Cool. Chalo. So let's start the discussion for electrochemistry. My slider, yeah, it has started. So let us quickly and very quickly, but at the same at same point start very steadily. So sir, what is this electrochemistry, sir? Beta, definitely everybody, each and every one of you know. सर तो क्या करें बेटा ट्राई फॉर तस्मीम टारगेट NITs because NIT Trichy, NIT Surathkal. Sir, your video are helping. Okay, your videos are helping me a lot. So thank you, studies. Thank you. And K Null, hi. You have posted so many highs, so hi. Sir, doubt, beta, I have not even started the class, but yes, please, if possible, I will definitely take that. Or sir, तो क्या NIT? Yes, beta. Tasmeem, you can definitely target NITs. Definitely, you can target NIT. So, what is this about electrochemistry, sir? Beta, electrochemistry basically deals with the interconversion of a chemical change. So, if I'm supposed to have any chemical change, chemical process, sir, but these chemical processes, if they are taking place by themselves, then I would rather name these chemical processes as spontaneous because they are happening by themselves. So if at all you have a spontaneous chemical process, that means somebody is, sir, what does a chemical reaction mean? That somebody is giving electron and the other species taking electron. Sir, you will teach the basics of beta. That is what I'm doing. I am defining the definition of chemistry, the chemical. What does chemical mean? So I am starting with at most basics. So rest assured, even if you know nothing about this, you after end of this session, you will be mastering the concepts of electrochemistry like anything. But yes, after the concept discussion, you are definitely supposed to read to practice the relevant number of questions so that you absorb all these concepts thoroughly, है ना? सर इलेक्ट्रोकेमिस्ट्री से सबसे ज़्यादा डर लगता है. दैट इज़ वाई बेटा आई एम पिकिंग दीज चैप्टर्स बिकॉज आई हैव बीन टीचिंग सिंस 2012 and I know, yes, definitely that was an offline format, but since 1 year I am there in online platform and I know what students face. So that's why I am bringing all these concepts, and that's why even I'm saying that I will be breaking this session in 2 halves. Hardly matters. School or only JEE? Beta, only JEE, only JEE, only JEE. But yes, obviously, sir, if you know some concepts, then definitely for your if you belong to CBSE board, beta, then your CBSE board also asked numerical and conceptual question from electrochemistry, that too of 5 marks. So out of 70 marks of your theoretical paper, 5 marks is of electrochemistry, and they generally ask 3 marks question numerical and 1 mark conceptual questions. So definitely it will be helping you for your boards as well. Chalo. So Perumal Krishna. I hope I answered that, beta. Now we have again Tasmeem. Sir, क्या हाँ बेटा NIT you can get, there is no cap for class 12 percentage. Aditya, sir, read my message. Beta, I am. Sir, why are no? Definitely, Mr. Raju, I am definitely not ignoring you. The moment you have written that message, I am reading it. I guess you have not posted anything before. Sir, kya? Haan. So, Tasmeem, yes, beta. NIT, again, I'm repeating, Tasmeem, you can get NIT if there is no cap for the class 12th board marks. Definitely, you should pass class 12 board that you have already passed. But yes, IITs can only be obtained because IITs make it a point that your class 12 boards has to be above 75%. है ना? Bhuvan, hello. Tasmeem, okay. Welcome, beta. Now, shall I start, sir? I am Bhuvaneshwari from PW. Okay, Bhuvaneshwari. Chalo. So, Bhuvaneshwari, okay, from PW. Oh, very good. Sir, board के लिए बेटा board के obviously for boards also it will be useful, for boards also it will be useful, but let me start now. Sir, if a spontaneous chemical process is taking place, sir, what does spontaneous mean, which is happening by itself, and what does chemical process means? That there is transfer of electron. There is some species who is taking electron and there is some species who is giving electron. Sir, giving electron is called oxidation. If I lose electron, if somebody is losing electron, then loss of electron is called oxidation, because oxidation state will increase. And if somebody is losing, then somebody can only lose when the other species is ready to gain that electron, and gain of electron is called reduction, where oxidation state decreases. Now, because once you gain electron, you will acquire a negative charge. That means the oxidation state is bound to decrease. है ना? So, if a spontaneous chemical reaction is taking place, that means a spontaneous redox is taking. So why you're taking this name redox? Because what does redox mean? When simultaneous oxidation and reduction take place, is a redox reaction. Now, if that electron transaction you are utilizing for yourself, that means you are using this chemical change and using the the chemical process must be producing these electrons. Somebody is losing, somebody is gaining. Now you convert that chemical energy into electrical energy. Sir, this is what we are doing. Sir, this is what we are doing in our batteries. So this is the basic function of your battery, where a spontaneous chemical reaction takes place and you convert it into electrical energy and you use it in your mobile phones and every apparatus. Okay, sir. But sir, there are some batteries who are rechargeable also. Obviously, those are non-rechargeable. They will definitely do this chemical process. Chemical process has completed, and a time will come that they will stop giving this electrical energy. Sir, then, but sir, there are some batteries whom we can charge also, sir. Yes. So how come you can charge these batteries? Beta, you can obviously charge these batteries because these chemical reactions that are taking place, they must be reversible. And in order to, but sir, going from reactant to product was spontaneous. So coming from product to reactant will not be spontaneous. So I will now do the forceful act. How I can do that forceful act? Beta, I can use external source and I can provide electricity or electrical energy, but this electrical energy I am providing from an external source, and that external source is forcing the chemical reaction which is non-spontaneous. So it will create a non-spontaneous chemical change. It will create a non-spontaneous chemical change. That means, sir, this way the battery can be recharged. That's why you switch on your charger and you force your battery to again come to the initial state. So that means this is the discharge and this is the charging of that reusable batteries. Now, talking about chemistry, these cells where you convert electrical energy and bring a non-spontaneous chemical change is known as a electrolytic cell, is known as electrolytic cell. And the cell where a spontaneous chemical reaction takes place and current and electricity is created, that we term as a electrochemical cell. So this is all about electrochemistry. This is basically all about electrochemistry that we are going to deal now. Let us start with this electrochemical cell. That means, sir, definitely a redox is taking place. Now, sir, how the hell you can use those electrons which these reactants are interchanging or exchanging among them? A very common sense, and that common sense, I guess you know. That common sense, I guess you know from class 10th. How, sir? I do not know it. Let me explain it to you. Now, let us assume, beta, let us assume I have a container over here. Okay, sir. This container is filled with water. Okay. So technically water is not a conductor. Why? Because water gives H plus ion and OH minus ion to a negligible extent. Not even considered. Water is definitely Water is definitely a substance which we know that it gives H plus and OH minus ion, but that is the ionic equilibrium logic about dissociation of water. So let me independently give you that ionic equilibrium about water first, and then we'll discuss about this, that why water. So I am saying this water is not considered, it is not even considered as what? As an electrolyte. Why, sir? The reason it is not considered as an electrolyte, beta, because if you have water, this H2O liquid definitely dissociates into H plus and OH minus. And sir, come on, yaar. You said it is not electrolyte, sir, but now you're writing its dissociation, its ionization. Let me complete myself. What I'm saying is, let's say at time t equal to 0, you have C concentration, as in molarity, moles per liter. So initially you have no ions. At whenever, sir, every reaction reaches equilibrium, definitely correct. So let's say at equilibrium, 1 minus alpha, as in C alpha of water has dissociated, where alpha is its degree of dissociation or ionization. So one molecule will form one H plus ion and one OH minus ions. That means C alpha will be forming C alpha and C alpha. Sir, what never changes? Beta, equilibrium constant. So equilibrium constant, which can be determined experimentally for water, can be written as concentration of H plus ions at equilibrium into concentration of OH minus ions at equilibrium upon concentration of water at equilibrium. Now point is, beta, this water is not at all dissociating because we know the value of K. So because we know this, that means, sir, out of so many molecules of water, very few molecules of water are dissociating, sir. But prove it, no, because you are saying that water is not an electrolyte. You have written that, but here you have written its ionization constant. Now let us go to Mother Nature. So in order to prove, we have gone to Mother Nature and we have seen the pH, the H plus ion concentration of water. So at 25 degrees Celsius, probably the room temperature, the H plus ion concentration given by water at equilibrium is nothing but 10 raised to the power minus 7 moles per liter. Sir, is this an experimental value? Yes. And technically you even know this value. Because what is pH? Sir, we obviously know. If you do not know, I'm telling you, pH is a mathematical operator, which means minus of log base to the base 10 of whatever. So because I'm having H plus ion over here, so pH is nothing but minus of log of H plus ion concentration. And for water at 25 degrees Celsius, I've experimentally given you the H plus ion concentration, which is 10 to the power minus 7 moles per liter, as in molar. So this will be log minus of log of 10 raised to the power minus 7. That means pH of water is 7. That's why whenever we say pH at 25 degrees Celsius is 7. That means it is a neutral solution because whatever H plus given by water is only existing in equilibrium, and water is not an electrolyte. Still, it is not clear, sir. You are saying it is giving H plus ion. That means it is ionizing. And then still you have written it is non-electrolyte. So let me now give you the mathematics behind it. Now we know what is H plus ion concentration. Sir, because water gives equal number of H plus and OH minus ion, that means H plus and OH minus ion concentration both are same. Definitely correct. So can you tell me what is this C alpha? Yes, beta. This C alpha is nothing but H plus ion concentration. So this C alpha is nothing but H plus ion concentration, which I know is 10 raised to the power minus 7. Now, can you calculate the value of alpha? Yes, sir. Beta, alpha will be 10 raised to the power minus 7 upon C. Now, what is C? Sir, this is the concentration of water that you have taken. What is C? Sir, molarity. What is molarity? Moles of water present in 1 liter of solution. The solution is of water only. So what is the number of moles present in 1 liter of water? Water is a beautiful solvent having density 1. So 1 liter water is equal to 1 kg of water. So number of moles present in 1 kg of water is weight of water upon molecular mass of water. So this will be 10 raised to the power minus 7 upon. Now instead of this molarity, sir, formula of moles is weight of water in gram, which is 1000 gram, upon molecular mass of water is nothing but 18, upon volume of solution is 1 liter, because we have considered 1 liter of water, because water has density is also 1. So sir, upon divided by 1, that do not even matter. That means, sir, this is nothing but 18 will come to the numerator, and this will become 10 raised to the power minus 10. 7 and 3 will become 10 raised to the power minus 10. Now you just see this alpha. What is the definition of alpha, beta? First, see the value of alpha. Sir, value of alpha will be, 18 upon 10 raised to the power 10. Now, let me give you an idea. Now you will say for yourself, no sir, water is not an electrolyte. How? You know what is 10 raised to power 7? Because we people understand rupees like anything. Because we all are definitely in love with money. Everybody is in love with money. Okay. So can you tell me in rupees format, how much is 10 raised to the power 10? Sir, 10 raised to the power 7 is 1 CR, 1 crore. And because I have 3, so this also I'm writing it as 18 upon 1000, as in 10 raised to the power 3, into 10 raised to the power 7, and 10 raised to the power 7 I'm writing as crore, because crore of rupees I know. So denominator, the total value is 1000 crore. And what is the definition of moles? Definition of moles is, a definition of degree of dissociation alpha is moles dissociated. How many of you have dissociated upon how many of you have taken initially. So initially taken. So how many water molecules have initially taken? 1000 crore water molecules. And how many of those molecules are dissociating? Yes, definitely some are, but how many? 18. Now you tell me whether you should consider this 18 or not by being money minded. This is the total value. So let's say your father, or yet let's say your grandfather is very rich. Assuming your grandfather is super rich, and he has called you, and you have whatever siblings, so whatever number of siblings you have, that is not even I'm considering. Your grandfather has called you, he is having a property of, he has 1000 crore in his bank account. What amount he is giving you? He is distributing money. He's just distributing money. He's very happy. He's distributing all that 1000 crore of rupees. How much money you are getting? 18 rupees. How much money you are getting? 18 rupees. So practically you get a fair share. No, you get something, no? You will say, sir, my grandfather has 1000 crore and I've got 18. Sir, I have got nothing. Now you will consider. Now you will consider water is definitely ionizing. But out of 10,000, out of 1000 crore of water molecules, how many water molecules are ionizing? Sir, 18. That means, sir, I will not consider this as ionization, sir. Point number one. Now, I hope everybody is clear with this. I hope now everybody will buy this, that water is not considered as an electrolyte, but this equilibrium constant K I will definitely use. Why? Because every reaction will be happening inside water, and what never changes, sir, equilibrium constant K will never change until temperature changes. So that value you can use for calculation of concentration of ions. I hope everybody is clear. Now let me just browse to those comments. Sir, can't we say simple that no hydronium ions and are same, so it is neutral? Nahi beta. Water is definitely neutral, but beta, after ionizing, there is independent existence of H plus and OH minus ions. If H plus and OH minus ions both are created, then technically ions are there, no? So I am using, yes, definitely it is neutral, but ultimately because ions are there, so you can say that because of those ions, I will be explaining this in the conductance. So if ions are there, then ions will conduct. If ions are there, then ions will conduct. Like for example, if I'm having water over here and let's say I take this assembly again, I am making this assembly blue. Intentionally, I'm doing it. Now, let's say here I have taken a metal dipped in water. Once you dip any element, any metal in water, water is not conducting. That means it is not producing sufficient number of ions. If I add, let's say for example, this is a zinc solid rod and I'm dipping this zinc solid rod in ZnSO4, zinc sulfate. Sir, but here also you have Zn plus 2 also and sulfate also. Then still you say, sir, it is neutral because it is giving Zn plus 2 an equal number of sulfate ion. So this salt, once it has gone in water, still the water is neutral. But now the water has become conducting because this is an ionic compound. It will completely dissociate and form Zn plus 2 ions and sulfate ions in equal amount. So the amount is still equal. That means you can still say this is neutral. Solution is definitely neutral. Solution is definitely neutral, but because of the presence of these ions, the solution is now conducting. Because in solution, what conduct? Sir, ions conduct. How they conduct? Because ions move, and because ions can move, so in a solution the conductance is due to the presence of these ions. And if you just take point blank water, then water is not conducting because it is giving very limited number of H plus and OH minus ions. I hope everybody is clear. Abhishek, I answered that beta. Anna, sir, how water molecules can dissociate into ions of themselves without a reaction or electrolysis? Please explain. Abhishek, I already explained beta. See, technically, out of 10,000 crore of water molecules, I am saying only 18 molecules are doing this. Now, if you are asking, sir, why the hell they are doing it, then the answer to that lies in chemical bonding. We definitely know water is this, a bent molecule. We definitely know oxygen is highly electronegative, sir. Because this is highly electronegative, that means the electrons of hydrogen is withdrawn away from itself. So that means, do you think this highly electronegative element, I'm not saying to very large extent, but can you deny to the fact that this cannot happen? I am not saying it is happening tremendously, but can you deny this, that no sir, it cannot even happen? An electronegative species which has a very high electronegative nature, which has high tendency to gain electron also, can't it take electron from hydrogen? If you have 10,000, if you have 1,000 crore molecules, can't even one or two or few molecules do this? If oxygen takes away this electron, then it will become OH minus and this will become H plus. Yes, beta. according through our chemical bonding knowledge also we can assume, sir, it can definitely take place. And once we have gone to mother nature, we have seen that this is taking place. It is definitely dissociating and forming H plus ion, OH minus ion, but yes, to a very limited extent. How we know? Experimentally. What is the experimentation? So the value of H plus ion concentration that we have calculated at 25 degrees Celsius. That means out of 1000 crore water molecules, 18 molecules are doing this, sir. That means ions are created. But sir, ions are very limited. And these limited ions are not able to make any to make water conducting. So in order to make water conducting, I need to add ions. Now this starts my chapter. So let us conceptually start our chapter, and this is actually starting our chapter. Starting our chapter how? Rajendra Kumar, hello sir, namaste beta. Sir, please reply me. Acha, Nikita, you are asking. Good sir. Sir, electrochemistry से 9 marks आता है बेटा. In CBSE boards, I guess 5 marks. In your boards, maybe 9 marks. But sir, we are talking JEE because one student asked. That's why I replied that. Then Bhumi. Hi sir, I am Krupa from PW. Okay, Bhumi, Bhuvneshwari, Krupa. Okay, Krupa. Kavyan is also here. So we have our Laksh JEE English students here joining me. So welcome everybody. Kavyan, Krupa. Then hi, Michelle is also here. Oh, Michelle. Sir, do you understand Hindi too or just only English? Beta, I understand Hindi, English and Punjabi because I'm Punjabi. Tasmeem, sir, NIT. Beta, Tasmeem, I already answered that. Hello, sir. Namaste. Good evening. Nikita, sir, please reply me. Nikita, you have not written, sir. Yes, sir. NEET के लिए कितने marks चाहिए class 12th में? There's no limit, Nikita. There's no limit. I mean, there's no bar. So for NEET, it's you just have to score well for your NEET examination. So Harshita Pandey, hello beta. Sir, मैं प्रयास 2.0 बैच से हैं. Okay. Amlan Pradhan, welcome Amlan. Welcome Amlan. Ellipse, good evening sir. Good evening. Abhishek Kumar, sir, when I asked this doubt to chat GPT, it replied that particles in liquid. Beta, that's why I know. That's why I know. Master, chat GPT, your AI can't replace master. So master and students, this relationship can't be modulated and animated. It can't be coded. So because we have x amount of variables with us, and therefore those variables can't be superseded by any artificial intelligence coding. So I mean that is good also. That is good also, or else our interaction will be gone, or else we will be jobless. But I definitely know that is not going to happen. है ना? चलो. Wrong name. My name is Harshit Pandey. Harshit, अरे यार Harshit, beta, please forgive me. I mean, technically, beta, when messages come, no, the names, some I error can be done. So Hitesh, hello beta. Hello beta. I hope everybody's with me till here. Now, let me move forward. Let me actually step into electrochemistry. Sir, let's say this is a solution of zinc ions. Definitely yes. Now if this zinc ion was comfortably there in its solution in the liquid solvent, I'm enjoying, I'm zinc ion. The moment you introduce this zinc solid, beta, there will be two tendencies that will be taking place. Why? Because the equilibrium will be getting disturbed. Sir, we know what equilibrium you are talking of, sir. Beta, as you introduce a solid into its own electrolytic solution. Now, what is the solid? Sir, zinc solid. What is the electrolytic solution? Having zinc ions. That's why I'm categorically using the same metal and the salt of same metal in the solution. Now, so sir, what equilibrium you are talking of? Beta, I am talking of zinc solid and Zn plus 2 aqueous. Once you introduce, initially in the solution you have only zinc ions. Once I am introducing zinc solid, the equilibrium will get disturbed. And sir, once equilibrium is disturbed, Once equilibrium is disturbed, you can think of equilibrium like this. You can think of equilibrium like this. Like if you have a track, then this reaction is at equilibrium. If you disturb this track, if you rather disturb this track, or the ball, that is reaction, can reach here. If it reach here, then it will proceed in forward direction to again attain equilibrium. If you have disturbed it in this way, it will again go backward, but ultimately it will again try to acquire equilibrium. Now my point is once you have dipped a metal into its own solution, it will also have two tendencies. One tendency will be moving forward. Some solid may further get dissolved, sir, but this solid getting dissolved is not just a physical change. Yes, you can definitely see the physical change, but sir, technically it's a chemical change. Why? Because zinc has an oxidation state of 0 over here, and here it is an oxidation state +2. So that means that this is nothing but oxidation. So technically, I'm not saying this can only happen, but yes, this is one of the possibility. I'll definitely show you the other possibility, but this is one of the possibility. So sir, if this is one of the possibility, that means zinc is getting oxidized, then show me the scenario over here, beta. I'm very happy to show you that. Now, because zinc is forming these electrons and Zn+2 ions are forming, the moment this solid will dissolve, let's say initially I have 100 molecules, 100 of these ions and 100 of these ions. Now, let me just remove these ions which are originally present. They are originally present because of what? Because of zinc sulfate. Equal number of zinc and sulfate ions. Now, let's say I'm not saying many. Let's say 1 molecule or 2 molecule or 10 molecules of zinc has extra been created. So they will form what? Sir, they will create extra positivity because Zn+2 are having positive charge. Because they have created extra positivity outside the solution, that means these electrons will be assembled here. Array sir, this is a picture of a capacitor, sir. Sir, this is a picture of a capacitor. Yes, definitely it shows a picture of a capacitor. That means charge is stored, master. That means charge is stored, sir. And if charge is stored, then this will definitely have some potential. Let's say this potential is V1. And this potential is called electrode potential. And this beautiful picture of potential is telling you that whenever a metal or an element is dipped into its own solution, then a potential is developed which is called electrode potential. That electrode potential will definitely depend upon the regain of the equilibrium. So that's why it depends upon the concentration of ions also. It depends upon temperature also. If you change temperature and concentration of ions, definitely the potential will change. So what I am considering in a general case. Any general case, some potential will be developed, sir, but you have not taken the other case. Let me take that other case also. The other case I'm taking with your class 9th and 10th logic, I'm linking. Let's say now I again have copper solid dipped in copper sulfate. Now, aqueous copper sulfate is also called blue vitriol. That's why I have intentionally drawn it with a blue color. And zinc sulfate, aqueous zinc sulfate is also called white vitriol. That's why even now this is an inorganic knowledge. You may skip it also. Sir, so beta, that is what I'm defining. Harshit Pandey, sir, how to become a topper in chemistry by studying beta. Sir, this is chemical change. Please repeat. I'm definitely doing that, beta. Harshit, I'm definitely doing that. Beta, if you dip any element in its own solution, such picture can generate. And because that picture has generated, that means, sir, charge has been, sir, can you see this picture of a capacitor? Yes, sir. Plus minus, sir, separated. That means, sir, charge is stored. And once charge is stored, that means, sir, charge stored will give this guy some potential. Now, I am defining this potential as electrode potential. Therefore, what does electrode potential mean? Whenever a metal, which is an electrode, is dipped in its own solution, then it will develop some potential with respect to its solution, not otherwise. With respect to its solution, it will develop some potential, and that potential is called electrode potential of this electrode in this solution. Why I'm saying this? Because as you change concentration, as you change temperature, everything will change. The potential value will definitely change. Sir, will we estimate that also? Yes, Nernst has done that experiment for us, and we will also do that statistical mathematical modeling. Now, smile silence. How to top JEE, sir? Smile silence. Beta, by silently smiling at the concepts again and again. Silently, as in, don't talk that you are working a lot. Actually, work a lot. And while working, always smile. Don't have this idea, "Arey sir, I have done 10 questions now, I should at least be AIR 1 or be AIR 10. Don't expect, because the result is not in your hand. What is there in your hand? To keep on working with a smile. But yes, that work has to be done in a silence. I hope so. Your name is giving the answer for your query, beta. And definitely you repeat this and you're going to top in your examination. I hope smile silence, I answered that. Akshara Reddy. Sir, your student got hi 99.99 percentile in chemistry JEE 2026. So 3 chairs for Akshara Reddy. Akshara, I definitely have seen this name a few times. Not you. You have not came a lot of in the live sessions, because else I would be. But yes, I am very happy to listen to this, beta. Which state you belong to, Akshara? Because you are saying your student, that means obviously you're talking about yourself, and I congratulate for this. I congratulate you, beta, for that great marks. Which state you belong to, Akshara? Chalo. Hello, sir. Hello, Jithin. So let us make this session interactive, beta. Obviously, we can. I mean, I love beta, par pata hai, there is a problem with me. Okay, Telangana. So all the very best, beta. All the very, very best. I'm so happy. And in fact, beta, these are the comments. These are the things which actually give motivation to us to come and serve you people again and again. So thank you, Akshara, for mentioning that. Telangana. Okay, beta. All the very best. God bless. Sir, where is your proper notes present? Hai? Beta, let me make that notes, or else Harshit, Mr. Pandey, if you are class 11 student, then join Laksh Arjuna JEE in English, because I am the chemistry educator over there. If you are in class 12, then join Laksh JEE in English, because I am the chemistry educator there. And by the way, if you want everything for free, then definitely we do that also, like I'm doing here. So once the live is done, my notes you can download from PWJE English WhatsApp channel. Anna? Thank you so much. Thank you, beta Akshara. Thank you. Thank you for mentioning it. So thank you and God bless. Chalo. Hello, Gully 1. Hello, beta. Hey beta, now stop writing. You know what? I am so fascinated with these comments that I will keep on reading the comment. I will not teach. Because even in my batch, I do that. I ask my students, I never switch off the chat. I mean, I rarely do it. I never switch off the chat. I always keep it open, because we have a one-to-one interaction inside our batches. So then I say, hey, stop. Then people stop. So yes, good. Vijay. Vijayank. Hello, beta. Now, let's start, shall we? Chalo. So, beta, sir, but you have not shown us the other scenario. So, show us the other scenario also. Beta, showing you the other scenario. The other scenario is, if you dip copper in its own solution, let's say copper sulfate, sir, other possibility can also take place, like, sir, the copper ions from solution can, because there will be two tendencies, no? If the equilibrium is disturbed, reaction can go forward also, it come backward also. So like for example, dissociation can also take place, sir. deposition can also take place. Here I have considered dissociation, solid getting dissolved. So here the solid metal must be getting dissolved. Sir, here, sir, opposite thing can also take place. So let us consider that opposite thing in a different one. So the opposite thing as in the copper ions, sir, where from where these copper ion came, beta, you have equal number of copper ion, copper and sulfate, both will be, let's say, 100. So some of out of those 100 copper ions, maybe after the disturbance in the equilibrium, in order to re-attain that equilibrium, few of the copper ions will take the electrons. Or from where the electrons are coming, the electrons must be, we will supply those electrons. You will see from where they are coming. If if those electrons are coming, because sir, this is a metal, sir, metal has free electrons, sir, so this copper will take those free electrons and will be deposited as copper solid. That means this guy will be leaving the solution and will be getting deposited here. This can be one of the tendency. Now what will happen to the charge separation? Sir, initially you have 100 copper and 100 sulfate ion. Because copper has gone, sir, so let's say 1 copper or 2 copper or 10 copper has gone, then proportionally, sir, 10 sulfate are now not neutralized. Let's say 100 and 100 were there, 10 copper plus 2 has gone. So now, sir, 10 sulfate are excess now, whose charge is not neutralized. So outside environment will attain what? Beta, it will attain negative charge. And inside will attain what? Sir, it will attain positive charge. Sir, again, sir, I can again see the picture of a capacitance of a capacitor. That means, sir, whatever phenomena is happening, either dissociation or deposition, whatever phenomena is happening, in all the possible cases, sir, capacitor will be created. That means a charge is stored. That means, sir, a potential will be developed. And this potential is called electrode potential. So whenever any electrode is dipped into its own electrolytic solution, a potential is definitely developed. And that potential here and here will be different. Why? Why? Because the metal, the elements are different, sir. So their tendencies will also be different, sir. So let's say this potential is V1 and this potential is V2. Sir, this we know from 910, sir. If you connect two different potentials with an electrical wire. So let me now connect them with an electrical wire. Let's say this is a switch. Let's say here I have a bulb, although this looks like a tree, but let's say it is a bulb. Sir, if you connect two potential difference, and let's say if you have closed the key, then sir, this bulb will glow. Why? Because sir, potential difference. And if two potential difference are connected through an electrical wire, then current will flow. And this is how we have created a spontaneous chemical change. One is getting oxidized, another one is getting reduced. And because of this redox transfer, current is produced. But sir, now you tell me, I am not using anything else. Low voice. Ashu Patra. Beta, for everybody voice is low or I'm audible? Everybody just give a confirmation. Everybody just give a confirmation first. Hello, hello, hello. Low voice. Ayush Patra is saying low voice. Now beta, am I audible? Am I audible, guys? Hello, hello, hello. Low voice. Anybody just give me a confirmation that whether I am audible or not. Ayush, now it is good or still you're feeling low voice? Okay, Kavyan, thank you. So Kavyan is saying audible. Voice is clear, or shall I increase audible? Okay. Ellipse is also saying audible. Then Ayush, beta, kindly you increase the volume at your end. Acha. So increase the voice beta, because from my end, I guess this is quite good. Quite good. It is in fact going till the red point. So I am quite, you just have to increase that decibel at your end. है ना? Chalo. No fixed voice. No fixed voice as in? Aryan Jha. No fixed voice as in? Good evening, Ashish. No fixed voice as in? Aryan? Good evening. Good evening, Ashish. I can see that. I have not seen you before. So welcome. Okay, sir. Chalo. Ayush, it is good now? Actually, you know what? I'm utilizing your query to sip some coffee. So thank you for asking that. Please take my name. Vedang Devrani. Vedang Devrani. So please, beta, I did. Shiba. Shib Amit. Hello, sir. I have doubt that how many time you have. Huh? Aryan, now voice is clear, sir. Okay. Good, beta. Chalo. That means you have increased the voice decibel at your end. Good. Chalo. Thank you. The where from electron come? Yes, beta. I'm definitely going into that now. Sir, your explanation is very nice, sir. Thank you, beta. Chalo. Beta, you know what? While studying, no, you should not have targets. Definitely, once you are in sync with the concept, na, the momentum gradually increases your speed like anything. But yes, I definitely feel this, that pushing things is actually not good, because once you push things that I have to complete till this, till that, then before the momentum is created, that is pushing, and that does not make you enjoy that does not allow you to enjoy the concept. So let us first enjoy the concept, and then definitely the momentum will be gained, है ना? Chalo. So sir, chalo, Mr. Aryan Jha, my name is Gaurav Singh Arora. Chalo, I hope now we can, shall we start now beta? If there are two potentials, and if I am joining these two different potentials with an electrical wire, then definitely, sir, current will come. Now, one of the student has definitely asked that, sir, from where we are getting these electrons. Now, obviously, in these two potentials, one will have a higher potential and the other one will have a lower potential. I think they pass through circuit. Nahi, beta, I have not used any other stuff. I'm just asking you, if I just close this key, will this bulb will glow? Answer is yes. This bulb will glow. Why? First of all, one experimental thing I'm telling you, that the potential of copper is more than the potential of this side. Sir, how you know? You will also know after the introduction of electrochemical series, which is definitely an experimental data of these electrode potentials. So because I know that data, so I'm telling you that electrode potential of copper is more. That means the potential of this right hand side is more. So because potential is more, that means the current will be traveling from this side. And sir, we know direction of flow of electron is opposite to the direction of flow of current. That means, sir, electron must be flowing from this side. This is point number one. Now, that means, sir, this guy, this terminal, this side of electrode is giving electron. Sir, you have already told us the loss of electron is oxidation, and the electrode at which oxidation take place is called anode. What is the definition of anode? Anode is that electrode at which oxidation take place. That means this is the anode among zinc copper couple. Now, now, sir, because zinc is giving electrons. That means the potential of this side is more. That means it is at higher potential. So higher potential terminal is marked as a positive terminal because higher potential. Then definitely this will become negative terminal. That means, sir, in electrochemical cell, anode is the negative terminal. And because this guy is receiving the electron, receive of electron, gain of electron, sir, you have already told us it's a reduction, and the electrode at which reduction take place is called cathode. Now, show us the picture, sir. Let's say I just talk of the first set of electrons. So then I'm very sure that here equilibrium must have been obtained. How? In this situation. And one zinc solid must have gone to solution phase and has formed extra zinc plus 2 ions, and those zinc plus 2 ions will be added in the solution. So one extra Zn plus 2 has been created. Initially it was neutral, but now the solution will become positively charged. Okay, sir. Electron gone, sir. Zinc came into the solution and electron gone. Okay, sir. Going. Electron came here. The moment electron has came over here, the copper plus 2 ion from the solution will take those electron and will be deposited as copper solid. So here you will see that, and here you will see that zinc, physically you will be observing that zinc solid will be dissolved. This is the physical thing that you'll be observing. And over there, because these copper will be getting deposited, so here you will observe that copper solid is deposited. That means that if you had 100 copper and 100 sulfate and one copper has gone, that means that one sulfate is now is not paired by the counter ion. So this solution will become negatively charged. Let me rub this copper, because after the first electron has gone, this solution will become positively charged and this solution will become negatively charged. Obviously you can see this bulb glowing, but sir, the increase of positivity and increase of negativity, the increased plus and increased minus, so this plus and minus will keep on increasing, and a time will come very soon enough, sir, the reaction will stop to take place. Why? Because the concentration will be increasing, and because concentration will be forcefully increasing, so this potential will just blow away, because equilibrium is continuously getting disturbed and it can't regain itself. So that's why, sir, because of the irregularity in the charges, I need this solution to be electrically neutral, sir. It is attaining positive charge and it is attaining negative charge. Initially you will definitely see this current, but soon enough this cell will stop giving you current. Why? Because these terminals will be getting charged, and this charge, which is plus minus here, this plus minus will be opposing each other soon enough. So I want this solution to be electrically neutral, and just in order to make this solution electrically neutral, I am introducing a U-shaped tube. In this U-shaped tube, I am using an electrolyte. But sir, that electrolyte will fall down. The solution of that electrolyte will fall down. So in order to make that electrolyte not fall down due to gravity, I will boil it with a substance called agar-agar, and then I will cool it down to form a jelly-like solid, and that jelly-like solid I will be placing inside it. And then this assembly is termed as salt bridge. And then this assembly is termed as salt bridge. And the salt bridge will have what? Sir, it will have salt. Salt to do what? Let's say generally we use some salt like potassium nitrate. So I have K plus and NO3 minus. The moment extra Zn plus 2 is created over here, the opposite ion, which is nitrate ion, will move and will neutralize this extra Zn plus 2 created. So again, the charge neutrality is maintained this side. Over there, the moment one copper has been deposited, sulfate will make this solution negatively charged. So the moment the extra sulfate is created, the opposite charge, which is K plus, it will move toward this side in order to neutralize the extra sulfate formed. Hence, the electrical neutrality of the two compartments are maintained. And sir, because it is also moving, so they should also move with same speed. That's why what type of you are not free to use any electrolyte. You should only use that electrolyte where cations and anion have same moving ability. The moving ability can also be experimentally determined, and the technical term is they should have equal transport number. What is transport number? The ability of an ion to move. So if they move with equal speed, then you will not have any potential loss. If somebody is reaching fast, somebody is reaching slow, then there will be some potential loss. What potential? Because this is also a liquid, so that is also, although a solid, because I don't want it to fall down due to gravity, but it is a jelly like solid, sir. That means ions are allowed to move. So this liquid and that liquid will also have some liquid junction potential. So I want this liquid junction potential and this liquid junction potential to be zero. And in order to make this liquid junction potential zero, I use such an electrolyte in this salt bridge which has equal ionic mobilities. I hope this is also clear. What is the function of salt bridge? So to make the compartments electrically neutral. I hope, and to close the circuit. Now you can definitely see this bulb, this electrical output for whatever purpose you are using will always be working. Now always be working till what time? Always? No, sir. Sir, a time will come when complete zinc will be dissolved. A time will come when complete copper will be deposited. Then the cell will stop functioning. And at that point of time, we have to replace this cell. Point number one. Or we can externally use a battery. And can make this process, and whatever zinc has been dissolved, I will make that zinc again deposit so that it is created again, and whatever has been deposited, I will make it dissolve. How to do that? By connecting a battery having more potential. Now can we calculate its potential? Definitely. But sir, in order to calculate potential, I need to know the concentration and temperature, because this potential will be changed if concentration and temperature will change. So first we will do this calculation for standard situation, and then we'll change the concentration and temperature, and you can calculate electrode potential at any concentration and temperature. Now this completes your electrochemical cell. Moving forward, sir, I hope everybody is clear with this. Now a very beautiful picture of the same zinc copper couple where we use Kc. There are many options of these electrolyte that you can use. Let us explore those electrolytes. So what is a salt bridge? Quickly, because theoretically and for JEE also beta, because they are very much interested in the statement based questions these days. So let me just read it for you. What is a salt bridge? Sir, a glass tube, which is a U-shaped tube, and it is fitted with an inert electrolyte. Now why I am specially mentioning inert electrolyte? Beta, whatever ion is moving to the compartment, the ions should not form a PPT, because once they form a PPT, if they forms a PPT at this junction, then sir, further reaction will be ceased, and if further reaction will be ceased, then sir, cell will stop functioning. So I definitely want electrical neutrality to be maintained, but I do not want this ion and this ion to form a PPT, sir, because then this liquid junction will be sealed because of that PPT formation. So what type of electrolyte you should use? So point number one is it should have same transport number, but here it is specially mentioning that it should be inert electrolyte. Now what are the choices of the inert electrolyte which are not forming precipitates also, and where the transport number of cations and ions are equal also? Sir, the famous examples are KCl, potassium nitrate, which I have already used, potassium sulfate and ammonium nitrate. Yes, and they are boiled with agar-agar in order to form a jelly-like substance, because in solid state even ions can't move. So if you want them to be conducting, then you have to allow the conduction. In order to allow the conduction, in order to allow them to conduct, you need a jelly-like substance. I hope everybody is clear. Hello, perfect. Sir, I got 9. Ritik Adhaya is saying, sir, I got 9,800 rank in JEE Advanced and got IIT Patna in first counseling. Should I take drop? Please guide, sir. Beta, technically, I don't feel you should. Technically, I don't feel you should, but if you rather feel that you have practiced to that extent that you deserve some better rank, then while studying at IIT Patna, while doing your first year, you can very well do the self study also coming back home and can again attempt, but rather not waste an year, beta. This would be my advice. है ना? Left side oxidation. Yes, left side oxidation is taking place, mind bot, and right side reduction is taking place. You can also remember this analogy. है ना? चलो, moving forward. So what about salt bridge, sir? Some more function. It forms a net light structure of porous, sir. The jelly-like substance, so the jelly-like substance is forming a net-like structure because it has been solidified. But because it is jelly-like, so among them the ions can easily move. The ions can easily move. So how these ions are moving, sir? Because it is forming a net-like structure or a porous structure which is allowing the movement of ions. Now, definitely this I have told you that in order to have no liquid junction potential, the speed of cation should be equal to speed of anion. Technically that speed is the ionic mobility of cation and anion should be same. How we justify and calculate this ionic mobility experimentally, we call that term transport number. So the one condition is it should be inert, second condition is the transport number should be equal. Now there is a point for JEE Advanced. I will not say for mains, but yes, rather a very beautiful point for JEE Advanced, because Advanced loves mixing inorganic and physical chemistry. Now, sir, we already have options. What options? Sir, KNO3, potassium sulfate, ammonium nitrate. But what I am telling you is that salt bridge completes the internal circuit of the cell as well as maintain electrical neutrality. This I know, sir. Moreover, salt bridge also minimizes liquid-liquid junction potential because we are taking only those ions which are having approximately same or equal transport number. Now, although potassium nitrate and ammonium nitrate have different speed, sir, why you have taken KNO3 and why you have taken ammonium nitrate? Beta, technically, if you compare with another electrolytes which are inert, technically KNO3 and NaNO3 has approximately equal transport number, not exactly equal. They have so a bit of liquid-liquid junction potential we consider. Why? Because although they have approximately equal, not exactly equal transport number, but we still prefer KNO3 and ammonium nitrate. Why? Because they have different speed of ions, but we have no other options because of the PPT formation. Let's say you have used chloride ion instead of potassium nitrate. Let's say you have used KCl, because KCl, the transport number of potassium ion and chloride ion are exactly same. But why we do not use it? Because generally chlorides are not precipitated. But if you have silver plus in your solution, if you have mercuric plus in your solution, if you have mercurous ion in your solution, if you have thallium in +1 oxidation state in your solution, if you have lead +2 in your solution, then in these cases, when they are present in the electrolytic solution, please don't use KCl, else you should use KCl. What electrolyte I have mentioned over here, let me use that slide changer where it is. What cell I have given you over here, beta? What electrolyte I have specially used over here? KCl, because ionic mobility of potassium ion and chloride ion are exactly the same, so that the liquid junction potential is minimum. But you should not use KCl. Rather, you should use potassium nitrate. And please bear with that minimum liquid-liquid junction potential. Why? Because this chloride ion will form PPT, and that PPT will just cease the reaction. It forms PPT when? If here or here, anywhere. Obviously, the chloride ion, the negative ion, is moving from which side to which side? Where is my salt bridge? Here. So the negative ion are moving toward the anodic compartment. So if you use Cl minus ion, then you should not use what in the anodic compartment? Sir, you should not use Cl minus ion if the anodic compartment is having these ions. Why? Because their chlorides are PPT. Now, from where I am extracting this, I'm saying it is very famous for advanced, because beta, the salt analysis of the cationic, of the group of cations, the group 1, group 2, group 3, group 4, 5, 6, and group 0, the ammonium cation. So there we know that there are some cations, for them the chlorides are insoluble and they get precipitated. Yes, generally chlorides are not precipitated, but if you have these metal cations in the oxidation half, in the anodic compartment, then don't take KCl, rather take potassium nitrate or ammonium nitrate. I hope this is a theoretical important point, but yes, good, valid for advanced. Now, liquid-liquid junction potential also I've explained that salt bridge neutralizes the charges of cathodic and anodic compartment, which leads to minimizing the liquid-liquid junction potential. I hope everybody is good. I hope everybody is good. PPT form kaisa hua, sir? PPT beta, if you have chloride and those cations, then they will form PPT. They will definitely go and meet the counter ion, and the moment Ag plus and Cl minus ion will meet, they will form a PPT. That means your first choice was to use such an electrolyte which is inert. Then chlorides in that particular cases is not inert, and because it is not inert, it is forming PPT, so you shall not use it. I hope everybody is good. JEE Advanced pattern change, sir. No, beta. Sin Chan, don't take any of those rumors. Yes, if at all anything is getting confirmed, we'll be the first one to be communicating that to you. Okay, chalo. Shall we move now? Moving forward, sir. Sir, standard potential. Now, sir, what is this standard potential? Now, if you have a metal dipped in its solution, sir, you have definitely told us a potential will be developed. But now let us calculate that potential. And how to calculate that potential, sir? It is very easy. We define some standard conditions. Now, what are these standard conditions? Let's say if I have water, if I have taken any ion over here, I am not interested, it can be any ion. Whatever element it is, the ion, the salt of that metal which I am going to dip, the salt of that metal I have taken. Now, if you dip any electrode, let's say this is M solid, then obviously, what can you observe, sir? We can observe this element in plus n oxidation state from solution can take up n electrons and can form this element as solid. Sir, why you are taking the reduction half only? Because you can definitely see in your electrochemical cell, that the cathodic compartment that you're having, Ansh, I'm intentionally taking the complete electrochemistry from basic beta, because technically this basic hurts, and don't worry, I will be making you also comfortable. Just let me move forward with the concepts. Now, sir, in the cathodic and anodic compartment, sir, in the cathodic and anodic compartment, the cathodic compartment was the terminal from which current was produced. That means that it was higher potential terminal. At higher potential terminal, what half of redox was happening? Sir, reduction was happening. That's why this is an IUPAC convention which says, according to our IU PAC convention for electrochemistry, we say that whenever we write electrode potential, you should definitely mean reduction potential. If a question is giving you that electrode potential for so electrode or for so element is this, then you should definitely consider that electrode potential as reduction potential. Now why IUPAC has done the sign convention? Because for our electrochemical cell, cathodic compartment is the positive terminal, that is the terminal which has had higher potential. So always remember this. If the question is giving you the value of electrode potential, it is writing electrode potential, then electrode potential means reduction potential. So that's why even I have considered a reduction potential. Now, so what is the standard condition? If you take the concentration of electrolyte as 1 molar, and if you do all such reactions at a temperature of 25 degrees Celsius, then whatever potential will be developed will be termed as standard electrode potential. Electrode potential is generally referred as E, and standard electrode potential is referred as E naught. So how can I write the standard electrode potential for this electrode? Sir, E naught as in standard electrode potential as in reduction. So M plus N to M. Now this is aqueous and this is solid. Now what is sir, this is how you represent reduction potential. Now this is definitely reduction potential, but because condition is standard, so this will be standard reduction potential. Let's say the value of this standard reduction potential, I'm just giving an example, let's say it is plus a volt, whatever it is plus a volt, then sir what shall be the value of its oxidation potential? Beta, then E naught M solid to M plus N aqueous will be standard oxidation potential, and this will definitely be minus times of this volt. Sir, why? Arey beta, come on, that is the KCL KVL that you can assume in within your head. Sir, if current is going in this direction, I'm taking plus 5 volt of a battery because this is a potential. So if we consider the electron flowing in the opposite direction, then we will have that potential as drop down. So drop up, drop down. So if oxidation potential, if reduction potential is plus a volt, then reduction potential of if reduction potential is plus a, then oxidation potential will be minus of that oxidation, that reduction potential. I hope everybody is clear with that also, sir. But how you have calculated this potential, sir? Because you can only calculate the reading of the voltmeter. And in order to, sir, read a voltmeter reading, you need two different terminals, sir. How come you are calculating this potential? Now, in order to calculate this potential, we have to choose a reference. That also IUPAC did for us. The reference that was chosen was hydrogen. And that's why let us now understand what is standard hydrogen electrode. Sir, hydrogen is not a solid, sir. Sir, hydrogen is not a solid, sir. Make hydrogen electrode first, sir. Okay, beta, making. Now, let's say I have this electrode. Okay, sir. Now you can again take water. Okay, sir, taken. Now, because I need to create hydrogen electrodes, so definitely I need H plus ions, because this is standard condition. So let's say the concentration of H plus ion is 1 molar. Because I'm talking in standard condition, so let's say temperature is again 25 degrees Celsius. But sir, hydrogen is not a solid, sir. How will you create that terminal, sir? Because charge carriers in the solution are electrons, but charge carriers outside are metallic wires, sir. And the electrodes, sir, which are metal, sir. Hydrogen is not a metal, but you can create one. How, sir? Let us use an inert metal. What is the most exclusively used inert metal? Sir, most exclusively used inert metal is platinum. So let's say I have used platinum solid. Now platinum solid will not react because that is a most precise inert metal. But sir, on a metal, on a solid metal, you can make gas, absorb. I'm not saying absorption. Absorption is this the association in the surface of a substance. So in this solid surface, if I use If I use a flask, a glass chamber, and in that glass chamber, if I pass whatever gas, because I need to create hydrogen electrodes, so I'm passing hydrogen gas. So these hydrogen gas will be quickly and comfortably be adsorbed. Be adsorbed. I'm using the word adsorption. Now, what I'm doing over here, I'm activating this solid. How I'm activating? You just take crushed platinum and paste that crushed platinum on the platinum surface. Why? Because then the surface will become rough. And rough surface will have more surface area. More surface area will allow more hydrogen to be get adsorbed. What is this, sir? The same thing I'm using. I'm increasing the surface area so that more and more hydrogen is getting adsorbed. That means that means just for the passage of electrons, I have a metallic carrier not participating. It is just a carrier. It will just allow the electrons to flow through. Platinum is itself not participating, hence I've used a inert metal carrier. And whatever electrode I wish to form, like here I need to form hydrogen electrode, so I'm passing hydrogen gas, sir, because it is standard condition. So you have to give the standard value for pressure also. Yes, so the standard value chosen by IUPAC is 1 bar. Yes, if you change this pressure also, sir, value will change. If you change this concentration also, value will change. Value of what? Of potential. And this is, my friend, this is termed as standard hydrogen electrode. So what will be the potential, sir? We will consider the reduction potential. So let us write the reduction reaction. So the electrode reaction, because this is just an electrode. So the electrode reaction will be, and obviously because we are considering reduction potential as electrode potential, so I'm writing this in the reduction half. So hydrogen from +1 to 0 is oxidation state decreasing. So H plus from the solution will take those electrons and will form hydrogen gas. This will be your reduction half of the reaction. This will be your reduction half of the reaction. And sir, what will be its potential? Its potential will be EH plus 2 H2. So this is reduction half, +1 to 0. But because we are doing it in standard conditions, so this will be not. I am not saying this value will be 0. No, no, no. I'm not saying this value will be 0. This will be some value, but I am assigning this value to be 0. I, as an NCRT, assigns this value to be 0 volt. So obviously, sir, if its standard reduction potential is 0, so standard oxidation potential of hydrogen will also be 0, because minus times of 0 is again 0. So this is standard oxidation potential. So both are 0. I am not saying it is actually 0. It is assigned. It is assigned as 0. And sir, why it is assigned as 0? Now you take this electrode on one side and you take any electrode on the other side and you connect this with a metallic wire, and now you add any voltmeter on the other compartment. This voltmeter will definitely give you a reading, where, sir, this will give potential difference. The one potential you have assigned as 0, so whatever you will be connecting on the other side will be the value of this voltmeter. And that is how you can calculate electrode potential of all the possible electrodes that you can form. That electrode can also be a gaseous gaseous ion electrode, because, sir, for gas also now we have a trick. We will use a inert metal, and in that inert metal I will just induct the whatever gas I want to create the electrode for. So this will be a gaseous ion electrode. I hope everybody is clear. I hope everybody is clear. I hope everybody is clear. Chalo. Now, sir, now we know, sir, electrode potential also, standard value, not actual value, but sir, standard values. Acha, let me just see those comments now, because I have not been reading those comments because I wanted to move forward. One guy said level up. Beta, my JEE rank was 6,000 back in the year 2006. So you know how I can level up. And you know what? Technically, as a student, chemistry was my weakest subject. There is altogether different story why I'm teaching chemistry. So level of come on. But yes, in order to move forward, I need to speak more. Acha, chalo. Now let me read those comments, and by the time. So technically, this is break, beta. Technically, this is break, but we are not breaking up. I mean, we are not taking a break. We are just holding for 3-4 minutes so that we can at least communicate. And I can. Yes, beta. Hydrogen. Did you study from Bihar? No, beta. I studied from NIT Kurukshetra. Uh, Back in the year 2006, I took drop. 7, I got into the college. 11, I passed out. Electrical engineering. Mind, bot, send. This sir. Eh? Sir, shirt arm is twisted. Twisted. Chalo. What else? हाइड्रोजन इलेक्ट्रोड पोटेंशियल को ही स्टैंडर्ड क्यों लिया गया? Hydrogen, because beta, technically the value that you have obtained, the value that you have obtained for various electrodes, out of those values, hydrogen was only selected as reference because of the fact that it was an intermediate value, beta. I mean, whatever electrodes we see around us, hydrogen was an intermediate value. So for example, if you have no origin, even if you talk mathematically or geometrically, origin 0, 0 is lying in between. You can have negative also and positive also. So technically we were choosing that element which is midway. What does midway mean? The tendency, sir, what potential you have considered to mark and to estimate all the electrodes, sir, because cathode was the higher potential terminal, so we have considered electrode potential as a reduction potential. So now we are comparing the reducing power of species, and hydrogen has an intermediate reducing power. That means there are many species which have less reducing power also. There are many species which have more reducing power also. So technically it was a more preferred option because its reducing power was midway between the known elements. I hope that is clear. Mindbot, I'm answering you. Sanjeet, hello beta. Ashlesh, oh Ashlesh is my Laksh student. Acha, sir, if you what are you asking beta? If 11th is wasted, eh? What are you asking, Wasawa? Mind bots, beta, I don't know what you are saying. Discord. I am not Gen Z. I am a bit old, so I can't answer that Gen Z type of questions. You have written mind bot eh? Send your Discord. So I can't interpret what you have written. By the way, you're always welcome to come to my place. Have you seen Gangs of Wasipur? There are few places still like that. So I belong to a MP-UP border place. So that's a hint. So you're always welcome. Sir, your YouTube, Sir, your YouTube channel, my YouTube channel? No, I don't have. Yes, back once COVID started, we were having those offline batches, and just to cater those students, we have done few classes, but else, sir, is this class full in English? Yes, Josh, it is full in English. Just to read the word, read the name of the channel, it says PWJE English. Sir, I am from Dash and I can think Dash. Okay. So, Wasawa, nice, no? I read it beautifully. Anna. So whiteboard is telling something about whiteboard. Then we have Faizan. Sir, offline, online? Definitely beta online, because I have been teaching offline since 2012. And you know what? As offline teacher, even when I used to go to a class, technically after teaching for so long, you do not have to prepare anything. So it is just how my day is going that used to decide what the way I'm going to teach. But in an online platform beta, even like if you just ask me, I have stopped using books since 2016. Not required. But now I feel, and why I feel, because this content making, that after the slide that will come, after that slide this will come, you have to put in that much of homework. So as a teacher, I'm telling you the efforts and the input that is required for a teacher to deliver an online lecture and an offline lecture has huge difference. The teacher also has to do the same amount of homework. Even the teacher is repeating that lecture n number of times, because every time the lecture delivery and the next lecture delivery will have to be planned accordingly. So because I'm just speaking as a teacher's point of view, that I am putting more efforts. If I teach this same content offline, it is good to go. So that's why I feel definitely offline, definitely online. But yes, for those students who are disciplined enough, if you're not disciplined enough, then rather that's a problem. But then that's a problem in offline also. So it is your discipline who is defining it, है ना? Now, uh, now, sir, is HCV enough for mains? Beta, HCV actually not even required for mains, but yes, partially yes. Solved examples, a bit of exercises, but yes, obviously Shreyas Sir, Sumit Sir, Gokul Sir, they will be more uh, appropriate to answer that question because it pertains to physics, है ना? Okay. Sir, I'm student of Lux JEE, so can I watch this? Huh? You are student of Lux JEE in English? Then I will be knowing you. Just write your name. Or you are Hindi batch student. Then if you are Hindi batch student, then definitely beta, we are teaching electrochemistry. Sir, types bhi hai. Okay. Sir, I'm student of Lux JEE. Yes, you can definitely ECM. I answered that. ECM, sir, I answered, bhaiya. Irido, beta, obviously valid for advanced, but that is a question you should throw at your physics faculties. Aditya Yadav, sir, I'm unable to manage all three subjects. Beta, that's a case for most of the students. So management is the thing that will outshine you. So you have to make that time available for yourself, because other people definitely are. Sir, please provide me a laptop I secured in 10 board. Beta, definitely just put that thing in the after the live, put that thing in the comment section. We'll definitely consider. But yes, there should be some grounds also. But still, I mean, if that's a desire you have, you should definitely put that forward. Now, no, sir, English batch. Okay, I got that. So definitely, beta, you can. Ashlesh, chalo. Now I'm starting. है ना? Now. So that means we have chosen a reference electrode, and that reference electrode and that sir, give me a shortcut. Sir, okay. Chalo, hey, I'm teaching now. So, beta, hey, pata hai, I get so much interest with these comments that I can't tell you, but I have to teach. So allow me. Chalo, moving forward. Now, what I'm saying, see, this is what happens in offline class also. There are few classes ones where we used to just have chit chat with students. So I love it because students make you feel alive. As a teacher, you feel alive once you speak to students. So obviously, I love uh, interacting, but there's a job to be done, guys. Vasava is now saying, Sir, I love you. You're the best of the world teacher. Okay, thank you, Vasava. And electrode potential. Love you, sir. Dheeraj, love you too, my friend. Sir, you give me a I give me a shout out. Sir, you are the best chemistry teacher. Thank you. Beta, everybody is best. Okay. Okay. Chalo. Thank you, everybody. Now, let's start, beta. Ashlesh starting. Ashlesh starting. Now, I hope there is Balaji is not here, or maybe there will be a case that Balaji has changed his name and he has come over here. Balaji is one of our Lux Jain English student, a very bright student, but a very sir, best book for chalo. Sir, where are you from? I can't reveal that. Come to the batch, then I'll reveal. Let's talk. हाँ चलो, let's study. Let's talk. चलो बेटा. Now, sir, why we have chosen hydrogen electrode? Because hydrogen electrode we have chosen as reference electrode, and after choosing this reference electrode, I can calculate standard electrode potential of all the possible elements that exist for us practically. And after calculating all the electrode potentials, what we have came through, sir, we have came through a series called electrochemical series. Now what is this electrochemical series? Sir, we have just calculated the value of electrode potentials. Sir, we have just calculated the values of electrode potential. And what is, sir, electrode potential for us? Reduction potential. And we have plotted these elements in increasing order, in an increasing order, So in this way, what is increasing? Electrode potential. What electrode potential? Standard electrode potential. If I'm writing just E naught, that means I'm specifically talking of the reduction potential. You can very well see for lithium taking electron and forming lithium solid, you definitely know, sir, these are alkali metals. So why metal will form a solid, sir? Metal will try to remain in Li plus aqueous condition only. That's why the reduction potential of it, you can definitely see it is minus 3.05, which is practically least. So that means this is having least reduction potential. So because its reduction potential is least, that means it will have least tendency to reduce itself. Talking in the opposite sense, sir, if reduction potential is minus 3.05, that means our oxidation potential is plus 3.05. That means oxidation potential is highest. That means who will try to oxidize itself to the fastest tendency? Sir, lithium. So that means, sir, if it is having a tendency to oxidize. So if I take lithium and compare it with any electrode which is coming below it, so this guy will try to oxidize itself spontaneously. Therefore, whatever you have in the top, that will always try to act as anode. And whatever you have at bottom relatively, that will be spontaneously assigned what terminal? Sir, it will be assigned terminal of cathode. In another inorganic sense, what I can say, sir, because the species at the top do not want to reduce itself, but in fact want to get oxidized. So if I oxidize myself, that means oxidation means loss of electron. That means I am giving electron. So if I want to oxidize myself, that means I will love to reduce you. That means the species at the top will be strongest. Reducing agent. Rather, I'm writing Ra as in reducing agent. Speaking conversely, the species which are falling at the bottom of this electrochemical series will want to become a cathode. That means they will have a tendency to reduce themselves. If I reduce myself, I will oxidize you. That means the species at the bottom are strong, or rather strongest oxidizing agent. So OA. So these are some inorganic knowledge we should definitely compare using the electrochemical series. Who is, sir, hydrogen electrode is not zero, sir. The hydrogen electrode, now where is that hydrogen reference electrode, sir? Here it is. See, this one. So hydrogen getting reduced is practically not zero. It is assigned a value 0. Sir, that means whatever elements are lying below or beneath hydrogen, sir, they will act as cathode, and in comparison to them, hydrogen will act as anode. So among these elements, hydrogen will act as anode, and rather they will be very happy to act as cathode. And that's why these elements which are lying below hydrogen in the electrochemical series can't produce hydrogen gas. So because we know because I'll definitely explain this afterwards, but let me just give you summary about this use of electrochemical series. That generally we know, inorganically speaking, metal plus acid forms salt plus hydrogen gas. Because what is happening? Because if I have a metal, let's say I have copper, or rather let's say I have a metal which is reactive. So let's say I have sodium. It is reacting with H plus. It will form Na plus and hydrogen gas will be released. In order to balance, it will be half because I'm just balancing Na plus and H plus. Sir, hydrogen, that means what is happening to hydrogen gas? Sir, sodium is getting from 0 to +1. That means sodium is getting oxidized and hydrogen is getting reduced. Yes, sir. Reduction takes place at cathode. So hydrogen can act as cathode for what elements which are lying above hydrogen. So obviously, you can see sodium is lying above hydrogen, sir. Obviously, all the reactive metals will be above in the electrochemical series. All the less reactive metal will be below, and all the moderately reactive metals will be in the intermediate, but yes, obviously above hydrogen. Now, similarly, let's say if I have copper, so copper solid once react with acid, let's say H plus, it will not produce hydrogen gas because hydrogen can't be reduced. Hydrogen act as a anode in comparison to these less reactive metals. I hope everybody is clear. Now, sir, can you give me rhyme for these less reactive metals? Yes, sir, definitely. So, although that rhyme generally you do not require, but still I am giving you a rhyme to memorize, because for some good questions sometimes it is required. Now what is required? Let me just give you that rhyme. Now what is that rhyme, sir? Beta, it is, now I'm writing that rhyme from the top, reactive metal. So it is Li ka pa ka na magal, act like a Bihari. So Li ka ba is my first rhyme. Ka na magal, after that man jan kar. Now before, beneath manjan, how manjan kar as in you brush your teeth. So for brushing your teeth you need water. For brushing your teeth you need water. So this is what? This is reduction potential. So how you do reduction potential of water? So water taking electron, who will take electron in water? So hydrogen in H plus, in +1 state. So it will form hydrogen gas and will give OH minus. So what is my rhyme? Li ka ba kana magal manjan kar. Then we have sun pub, and then we have hydrogen. Yes, I'm doing this down the series because I'm not having space, so I'm writing over there hydrogen. And after hydrogen, obviously, what are the less reactive metals? The less reactive metal rhyme is chap, CHAAP. What does chap mean? You just copy it down. So what is chap? Chap is C, stands for copper. H, let me write this with different color so that you can at least, any of you, if you're learning this rhyme. So C stands for copper, H stands for Hg, then both A are gold and silver, which is cheap, not cheap, but yes, relatively less priced, silver, and then gold, and then platinum. So obviously these metals will not react with acid and form hydrogens because they will always be cathode, and hydrogen in fact will be anode. I hope everybody is clear. So what is the rhyme that I'm giving over here? This rhyme you can definitely use for some questions, not all, because technically for mains level of questions you are generally given with the values of electrode potential. Now, sir, if anybody is having more electrode potential, sir, more electrode potential, then it will be lying bottom in the electrochemical series. And because they will be lying below the electrochemical series, that means they will be acting as cathode, and the elements which are having less electrode potential, that means they will be acting as anode, because electrode potential means reduction potential. I hope everybody is clear. Now moving forward, these are some applications of electrochemical series which I have already mentioned. So yes, directly now moving to the question. So the first question, a JEE mains question, is in front of you. You have to give me the order. At least read the question. I'm not giving any timer for this question, but yes, please read the question, because such questions are very, very, very famous and very doable also. So kindly just read the question. Everybody, just read the question, everyone. just read the question, everybody. Yes, beta. Maroof, how to manage JEE and school syllabus, sir? Beta, time is always a crucial thing to manage, beta. People are. To answer that, there are many students who are. So you can be one of those or you can't. Yes, in order to be, you have to be committed enough. So if you're not sleeping, you should not sleep for more than 6 hours. If you're not eating, you should only eat thrice or 4 times a day, and that too, it should only take 10 to 15 minutes. Then you should only study. So I'm just saying, everybody is having limited time, everybody is having their different set of efficiencies. So with whatever efficiency you're working, if you're not sleeping, if you're not eating, then study. Then whatever you are doing, that is best for you. But yes, be efficient also. No mobile phones. I mean, yes, for watching educational videos you can, but yes, no swiping up down, no shorts, reels. Chalo. I hope everybody is clear. Now, let us quickly do this beta. So the question says, uh, cobalt plus 3 taking electron forming cobalt plus 2. It is also mentioning reduction potential. That means it is also reduction. It is mentioning also reduction potential. So its value is, let us check. Let us just write the reduction potential for all. So this is also reduction, yes. So this is also reduction, yes. This is also reduction, yes. This is also reduction, yes. So what, sir? First of all, just check whether they are reduction potential or not. If oxidation potential is given, then convert it into reduction potential and then do the thing mathematically, because now we can definitely see who is having least reduction potential. So least value is this. That means, let's say Bi plus 3. Bi plus 3 is having least reduction potential. After that, sir, cerium plus 4. After that, after cerium plus 4, who has least value? Sir, Pb plus 4. Pb plus 4. After that, who has least value? Sir, cobalt plus 3 has highest among them. Now, this is the order of their reduction potential. Now, oxidizing power. Now you just judge for yourself. Sir, reduction potential of cobalt is highest. That means cobalt will try to reduce itself. If I will reduce myself, I will oxidize you, because I'm reducing myself, so I will oxidize you. If I will oxidize you, that means I am strongest oxidizing agent. So the guy who is having the highest reduction potential will only be the strongest oxidizing agent. So oxidizing power, who is the strongest oxidizing agent? In order to oxidize you, I have to reduce myself. Who is having the capacity to reduce itself? Sir, cobalt plus 3 has a tendency to go to cobalt plus 2 with a potential of 1.81. So definitely, I hope everybody is clear. Now, so my doubt is, I am okay. So to get IIT, Bombay, CSE, how many? Beta, that categorically depends and varies all the time. But yes, if you are having dedication and motivation, beta, then just try to finish NCRT and just try to finish NCRT solved examples and exercises along with the PYQ questions of JEE Mains. Then I'm telling you, because for JEE Advanced also 45 to 50% of the paper you can get in line of JEE Mains. But yes, you have to be at par with JEE Mains, and then definitely you can land to a comfortable seat. After that, start building and practicing advanced questions, and then by practicing, like for example, if you just attempt all the 10 years, 12 years JEE Advanced paper, beta, automatically you have to read some extra stuff, and that will make all the relevant topics at par with JEE Advanced. That is the best approach that you should follow. है ना? I'm answering Yash Misal. Chalo. I hope everybody got that. Now, moving to, there are some more questions. Chalo, attempt This one quickly, I guess this will take very less time, so quickly attempt this one. You this is a JEE advanced question. Yes, the format is different, but yes, you just have to give me an answer. Among them, which is the strongest reducing agent? So just the same logic you have to apply. Quick, everybody, quick. Which is the strongest reducing agent you have to answer? Which is the strongest reducing agent you have to answer? Quick. Chalo. Let us do it together. Now, for strongest reducing agent, sir, again, sir, reducing agent will reduce other. That means it will oxidize itself. So let us directly, because sir, I want reducing agent will reduce other, it will oxidize itself. So let us check the oxidation potential. Who is having best oxidation potential? So sir, this is the reduction potential. So oxidation potential, let us write the oxidation potential then. Then zinc will form Zn plus 2 and the oxidation potential will be minus of this. That means it will be plus 0.762 volt. So this is the reduction potential. So oxidation potential of chromium will be plus 0.74. This is a reduction potential. So oxidation potential of hydrogen will be 0 volt. This is the reduction potential. So who will get oxidized? Sir, ferrous ion will get oxidized, and its potential will be, sir, because this is positive, so it will be minus 0.77 volt. Obviously this is gone. This is having least oxidation potential. This is, yes, coming third. This is coming second, and zinc guy will have maximum oxidation potential. So who will be the strongest reducing agent? Your answer will definitely be not zinc plus 2 beta, but zinc solid. I hope everybody is clear. I hope everybody is clear. So first is the correct answer. Beta, there is no option, but I hope everybody got it now. है ना? Guys, I hope everybody got it. Chalo. Moving forward now. Definitely you can have more sort of these questions, but yes, sir, because I mean the concept has already been communicated to you. So these all are the practice questions which I'm showing you. Yes, let us do this one more. Let us do this one more because this is integer type. So giving you 30 seconds for this. Quick, everybody. Quick. Giving you 30 seconds to attempt this. Quick. Chalo. After this beta, we'll move to another topic, next topic. Now, the question says, the standard reduction potential values of three metallic ions X, Y, and Z are this, this, and this. So this is for X, this is for Y, and this is for Z. The order of reducing power. Now, sir, reduction potential, reducing power, that means reducing agent. So if I'm a reducing agent, that means I will reduce you. If I reduce you, then that means I will oxidize myself. So who will have maximum oxidation potential? Sir, maximum oxidation potential, because it is reduction potential. So X will have, these are reduction potential. So standard oxidation potential of X will be minus 0.52. It will be plus 3.03, and it will be plus 1.18. So who is having maximum oxidation potential? Sir, Y. So Y will be having highest reducing power. So Y having highest, only one option. So definitely option 1 is your answer. Yes, definitely after that Z, and then least is X. So A is your comfortable answer. I guess poll is not working, but I hope now everybody has got it. Now moving to the next, but rather the important. Yes, great beta. Yashmi Sal. Now great. Now because this is, I guess, 9-5, so let us do this beta. 9-6. So let us do this. Let us meet again at 9:15 and quickly take some bio break. You also get up from your seat, go have some water, have some food, and just come back in 5 minutes, in 5-10 minutes, because I want each and every one of you to come back, because this is going to be a good topic, a great topic. So I want everybody to reassemble at 9:15. So please come back, it will definitely be helping you. Okay, so 9:15 we are meeting again. Okay, chalo. Everybody, welcome back. I hope everybody is back now. Let me just set the brightness again. Now, I hope everybody is back. So, whoever is there with me, please respond whether I'm completely audible and visible, guys. Guys, just let me know in the comment section that whether I'm completely audible and visible. Shall we start? Chalo. Uh, Tasmeem again. Tasmeem, I already answered all your queries, beta. Yes, sir. Force gaming. Perfect. Yes, sir. Punisher boy. Utsav Raj. Everybody. Sanjeet. Chalo, beta. Let's start now. Thermodynamics involving equilibrium. Now, beta, we definitely know thermodynamically if any process is spontaneous, then who determines the spontaneity of the process? Sir, Gibbs free energy change. And thermodynamically we should know, all the students should know this, that delta G is nothing but delta G naught plus RT ln of Q. Now, if at all a reaction is taking place, then Gibbs free energy change is equal to standard Gibbs free energy change plus universal gas constant into Kelvin temperature into ln of, as in log to the base E of the reaction quotient of whatever reaction has been taking place. Now, at equilibrium, beta, once equilibrium is reached, sir, my cell will also stop working, because whatever reactions are taking place, sir, complete reaction has taken place and it has reached equilibrium. So once equilibrium is reached, delta G becomes zero because there is no useful work work done by the battery, and Q will be equal to K. That means I can say delta G naught becomes equal to minus RT ln of K. A very important conclusion. Now let me relate this useful work for the battery. So we definitely know through our physics understanding that potential is nothing, sir, but it is work done to move a charge. Now, I am focused in the work done by my electrochemical cell. So because my focus is on the work done by the electrochemical cell, so work done by my electrochemical cell will be nothing but potential of my cell, which is E, into the charge that is flowing through the cell. Now, sir, this E is definitely my electrode potential, and this work done, sir, the useful work is delta G. And if I consider my potential in the standard condition, then at standard condition, I can say at standard condition, I can say that, sir, what is the useful work done at standard conditions? Sir, delta G naught, because delta G is my useful work magnitude as per thermodynamics. And this will be equal to, sir, the cell potential. Now, what is the cell potential, sir? E naught cell. E naught of the cell or of the electrode, whatever. Now, sir, now tell us about the charge. Now let us assume a basic reaction. Let's say I have any electrode M plus N taking N electrons and forming elemental M. Sir, if I have 1 mole of this guy forming 1 mole of this guy, sir, how much charge will be used? Sir, N moles of charge. Now what is charge on 1 mole electron? Sir, charge on 1 mole electrons will be sir, one electronic charge, which is 1.6 into 10 to the power minus 19 coulomb, into 1 mole, which is 6.022 into 10 raised to the power 23. Now everybody, I guess, know that this is 96487. Approximately this is 96500 coulomb, and to this charge I say 1 Faraday of charge. This charge I say 1 Faraday of charge, sir. But here 1 mole is utilizing n mole of electrons. So the total charge will be n moles of n times of the Faraday value. And sir, electronic charge comes with a negative sign. Sir, electronic charge comes with a negative sign. So this will be minus. Let me just make space for the charge. So this will be minus NF E naught. So a very beautiful formula that is coming up through thermodynamics in front of us, that is delta G naught is nothing but minus NF E naught of that electrode. If we are talking for the complete cell reaction, then for the complete cell also. Now one more interesting thermodynamic property, which is, sir, this potential is an intensive quantity, sir. Now what is an intensive quantity? Which is, you should remember this by this keyword only, which is independent. IN, intensive. So this is independent. Independent of what? Independent of amount. It do not depend upon amount. Now what is this delta G naught, sir? This is work. Sir, work is obviously, it depends upon the amount, sir. So it is an extensive property. So if you add some reactions, of if you add some amount, then this will be getting added, this will be getting subtracted, you will have no effect, it will be unchanged. If it, because intensive property do not depends upon amount, a very crucial thing. So this is intensive and this is extensive. So if you add, if you subtract, if you multiply, this will change, but rather this will be independent of that change. Now this, in fact, this formula also and this idea also is very much loved by JEE also, and it is very much loved by JEE Advanced also. I hope everybody is clear. Now let me browse. Now let me browse to the type of questions that we get along this. So for example, the standard free energy change for the following reaction is given. That means this is the value of standard Gibbs free energy change, as in delta G naught value is given to me. Now, what is the standard electrode potential for this half reaction? This is an electrode potential where ferric ion is forming iron. Now, so that means delta G naught will be equal to minus NF E naught, and this E naught will be the electrode half, which is ferric turning to Fe. So this Fe, this E naught can be calculated how? So value of delta G naught, which is minus 210, the SI unit of energy is joule, so into 10 is power 3 upon, because that is in kilojoule, upon this minus. So this minus will be plus. What is the number of electron transferred? 3 into 96500. Whatever you will get will be in SI unit, which is volt. I hope you can simply solve all the questions. All the options are in a positive value. So this is just a mere calculation that you have to do, and you'll get so many questions of this format. Point number 1. Now, we are you here? We? Why? Chalo. Sir, I do not remember. What don't you remember, beta? Aesthetic man. Sir, I'm dropper. I don't take foundation. What do I do? Beta, I have started this chapter with foundation only. Don't worry. You just have to read this from the start, and then definitely you will get an idea. Now, aesthetic man is asking, sir, please answer me. Beta, your question is what? Why this could happen? What could happen? What? I can see Tasmeen comment, and then after, chalo, I hope you can put that comment, your question, in the comment section, and definitely I would love to answer that. Now, moving forward for this point, sir, next thing, if the equilibrium, sir, we have related equilibrium constant also with delta G naught. So delta G naught is equal to RT ln of K. Now, equilibrium constant of the cell is given as 10 raised to power 9. So what will be delta G naught? So delta G naught will be R is 8.314 joule per mole per Kelvin, because I need to calculate this in joule. Set temperature, because it is asking the standard value. So standard value temperature is 25 degrees Celsius, as in 298 Kelvin, into, because ln value I cannot calculate but log I can calculate. So ln of x is equal to 2.303 into log of x. So log of 10 raised to the power 9, because that is the value of k. Log of a raised to power d, log of a raised to power b is b log a. So this will be 9 log 10. Log 10 value is 1. So this is nothing but 9 into 1. Now, because you have to report in kilojoules, so I have to divide by 1000. Whatever answer you will be getting, that will be in kilojoule per mole. Now again, this is just a case of multiplication, and delta G naught is equal to, yes, so this is just a case of multiplication after this. I hope everybody can do that, and I guess once you solve, you will be getting somewhere around 51 point something. So 51, 52 will be your answer. I hope everybody is clear. I hope everybody is clear. Chalo, perfect. So please reply. What beta? Tasmeem is also saying, Tasmeem, I answered all your questions regarding class 12 going to NIT, but yes, because 60%, so yes, you can only aim for NITs. Sir, NIT के लिए class 12 में कितने marks चाहिए? Beta, that depends upon, technically for JEE mains, for a good NIT, out of 300, you should definitely score around 200. For good NITs, around 200 or maybe plus. Why? Because maybe your session will have easier paper, than cutoff may go high. So you should only practice. Yes, Utsav Raj, perfect. That is 51.35. Perfect, beta. Perfect, Utsav. Now, I hope is because he has answered. So let me write that answer also. He's saying 51.3 something kilojoule per mole. Perfect, beta. Now, moving forward, sir, you said potential do not depend. So if chromium taking 3 electron, forming chromium plus 3, the potential is a volt. So if twice of chromium is doing that, then still, sir, potential will again be a volt. Why? Because, sir, potential is intensive. It is independent of amount. It is independent of amount. But rather, what depends upon amount, sir? Delta G depends upon amount. So delta G for this reaction will be, delta G naught for this reaction will be minus N. Now number of electron transferred are 6. So it's minus 6 F into E naught. Now E naught of this is again A. So this will be minus 6 AF. I hope you get this idea that delta G depends upon amount, while E naught is independent. Now this is beautifully used by JEE. How? Let us quickly browse to a JEE Advanced question on using how to justify this, how to use this idea of intensive and extensive quantity. JEE mains also asks such questions a lot of time. Let us do a good one. The reduction potential of this you have to calculate. That means you have to calculate reduction potential of what? Sir, MnO4 minus changing to Mn solid. Let's say this is my reaction for which I need to calculate delta G, I need to calculate E naught, which is potential. But let me just write that this reaction has delta G as delta G, because it is talking of standard conditions. So let's say this is delta G naught. Now, sir, just tell me the number of electron transferred. Beta, you do not have to balance the reaction. You can just identify the oxidation states. So here X minus 8 will be minus 1. So here manganese is in plus 7 oxidation state. Here it is in 0 oxidation state. So what is the number of electron transferred? Beta 7. I hope everybody is clear with that. Now, what are the given data? So given data are MnO4 minus turning to MnO2. Let's say this reaction has delta G of delta G naught 1. Sir, why you are taking delta G not potential? Because potential is given, because beta potential can't be added and subtracted, but delta G can be. So that's why I'm directly writing delta G. We'll calculate delta G now. But sir, give us the number of electron transferred, giving beta. Here this is plus 7. Here it is plus 4. So number of electron transferred will be, say, 3. Next one. So next one is MnO2. MnO2 forming what? Sir, forming Mn plus 2. Let's say delta G for this reaction is delta G naught 2. What is the number of electron transferred? Sir, from plus 4, it is going to plus 2. So number of electron transferred will be 2. Last one. So last one is Mn plus 2 going to manganese. Let's say delta G for this is delta G naught 3. Sir, what is the change in oxidation state? Beta, from plus 2, it is going to 0. So number of electron transferred again is 2 over here. I hope everybody is clear. Now, sir, this means if I add these three reactions, if you just add these three reactions, I hope everybody can clearly see this MnO2 will be cancelled. So this Mn plus 2, this Mn plus 2 will be getting cancelled. You will be getting MnO4 minus, which I need here. You will be getting Mn, which I need here. That means that reaction can be created by adding all the three. So that means mathematically I can say, delta G naught will be equal to delta G1 plus delta G naught 2 plus delta G naught 3 as an equation 1 plus 2 plus 3. Now, sir, we know delta G naught for any reaction is equal to minus NFE naught of that reaction. Now, sir, minus and F will be here also, here also, here also, here also. So why bother? So kill minus F in your mind and only state. So 1.68 into 3 will be my first case plus second case. Sir, number of electron transferred is 2. So 2 into 1.21. So 1.21 into 2 plus, this is from the second case. And the third one is number of electron transferred is again 2, but here potential is negative. Why bother? Put it with sign. So minus of 1.03 into 2. This is for the third one. Now, this plus this minus this divided by 7 will definitely give you the value of E naught. Now, into divide, you definitely have to do, and once you do it, you will be getting 0.77 volt as your answer. I hope everybody is clear. A very important point, a very important type of questions, and such questions you get not one, a lot of time in your JEE Mains also, JEE Advanced also. I hope everybody is clear. I hope everybody is clear. Now, trick. Ram is asking, sir, trick. Beta, this is the only trick. This is the only common sense. So, common sense is your trick. Sir, I have brought the batch of dash. We cannot say those names, beta. And I'm feeling like I have taken wrong decision. Please give advice. Join us. Join Laksh JEE in English if you're a class 12 student. Join Arjuna JEE in English if you're a class 11 student. You will definitely have very personalized experience, beta. That too at a minimum, at practically no cost. चलो सर, तो एनआईटी में अच्छा कॉलेज नहीं मिलेगा 60%. सर, तो एनआईटी नहीं बेटा. Tasmeem, you are again asking those things. I have already answered, beta. NIT you can get even if you are having 60% in your class 12 boards. For getting a better NIT, you have to score better in JEE Mains. And for JEE Mains, you can definitely take a drop. Anna? Dheeraj Kumar is saying laptops. Sir. Put that thing in the comment section. The team will definitely maybe if Alak sir sees your comment, then definitely beta you are going to get one, because definitely you know sir loves students. Even we love, but chalo, moving forward. Now, I hope everybody is clear. Now, sir, you said that if you change concentration and if you change temperature, then cell potential will change. Sir, how it will change, beta? It is decided by Nernst equation. It is decided by Nernst equation. Utsav Raj Singh is saying, sir, my answer is 1.79. 1.79, this one. Let me just do the calculation, beta, for you. I mean, yes, into divide, beta, you have to be very, very vigilant with the into divide that you are performing. Let me just do it for you. 1.68 into 3. This is 5.04. Beta, this is 5.04. 1.21 into 2 is 2.42. This is 2.42. And this is definitely minus 2.06. So 5.04 added with 2.42 subtracted with 2.06 divided by 7. Nahi beta, this is 0.77. You must have done some calculation error. So this is exact your answer, hai na? Chalo. Sir, question practice. That is what we are doing, beta. Utsav, I hope your answer is correct now. Sir, NIT, हाँ, Tasmeem, I answered. Yes, beta. अच्छा कॉलेज नहीं मिलेगा. अच्छा कॉलेज नहीं मिलेगा 60%. बेटा नहीं, 60% is your class 12th. NIT is depending upon your JEE main score. Okay, sir. कैसे करें JEE का batch? Join us. Guruji, Assalamu alaikum, beta. Okay, sir, I got, perfect, in second chance. Yes, beta, you have to practice more. Now, sir, talking about Nernst equation. So let's say, beta, if you are having a reaction where sir, the concentration and temperature are changing, then how you should calculate, beta? Just write the reaction. Let's say you have a reaction A moles of A plus B moles of B forming C moles of C and D mole of D. Let's say this is a reaction that you have got after adding the oxidation and reduction half. Now, the cell potential according to Nernst will be standard cell potential minus RT upon NF. Sir, is it a statistical value? Yes, beta. So no derivation, at least you should directly know this Nernst equation, which is E cell is equal to standard cell potential minus RT upon NF into ln of the reaction quotient. And this reaction quotient will be nothing but, this Q will be nothing but concentration of products raised to the power stoichiometry, upon concentration of reactant raised to the power stoichiometry. Sir, for ions we'll write concentration, for gases we'll write pressure, and for pure solids and pure liquid, sir, they do not impact the state of an equilibrium, so do not write their concentrations, just neglect them. Now, sir, give a mathematically useful form. So mathematically useful form will be E cell will be equal to E naught cell minus, sir, R value is 8.314. So temperature, generally temperature, they do not change. They take 25 degrees Celsius. That means 298. Sir, N is a variable which will be decided by the number of electron transferred. Sir, Faraday number is also charge of 1 mole electron, 96500. Sir, Ln will be converted to log using a multiplier 2.303. So let us calculate all these value mathematically and it will come out to be 0.059, because this will help you to do your questions mathematically fast. So learn this also. But yes, number of electron transferred will be dependent upon the reaction that you're having into this ln will become log and then Q. I hope everybody is clear with this as well. Now, let us use this formula in a beautiful question. Beautiful as in, sir, what will be the graph? Sir, definitely we have seen this equation. Let me take that slider. So, sir, please plot a graph between E cell and rather ln Q or log Q. So definitely, if we plot E cell on RHS on the y-axis and ln of Q along x-axis, then we definitely know, sir, this E cell will behave as y. Sir, this is ln will be my x, or log can be also my x, and sir, this is a straight line with a negative slope. This is a straight line with a negative slope. That means, sir, this will be a straight line with a negative slope. That means, sir, electrode potential is going to decrease. What about this value, sir? This value will be E naught, the standard value, which is the intercept C, and the slope will be minus RT upon NF in case of ln, and 0.059 upon n in case of log. Please make sure you are checking this, that whether, because I have written ln over here, so rather let me write the slope as minus RT upon NF. I hope everybody is clear. I hope everybody is clear. Okay, sir, I have talked to my father and he has brought as in bought the batch Laksh English perfect beta. Should I have to buy the beta? At least go for the infinity section then, because infinity section will already give you all the modules, and those digital modules also you'll get, and you'll get infinite set of practice questions also. Along with that you will be getting the all India test series also complimentary. Sir, you will have test series once you join the batch also, but that will be giving you a rank within the batch Lux JEE English. If you want the complete PW students, because obviously most of the serious students all over India, whether they are studying anywhere, they take that PW test series. That's why you can have your overall ranking also. So that infinity batch, that's why helps a lot. है ना? Chalo, perfect. I hope everybody is clear till here now. Effect of cathode and anode with time. So technically, let me give you this example with zinc copper couple. Let's say for zinc, which is an anode for my electrochemical cell, I hope you remember this, and cathode is my copper. So let me write electrode potential for them independently. Sir, for zinc, definitely I know zinc will take Zn plus 2, these two electrons, and will form zinc solid. This will be a reduction of, although zinc is getting oxidized. But what we compare, sir, electrode potential. What is electrode potential? Sir, reduction potential. So electrode potential for zinc will be what? Zn plus 2 to Zn. Rather, because I'm saying electrode potential, so let me not write not over here. So that means E naught of Zn plus 2 to zinc will be, I have again written not. So E naught for zinc will be, so electrode potential for zinc will be standard electrode potential minus 0.059 upon number of electron transferred is 2 into log of, now what will be the, sir, pure solid will not impact, so product is 1 upon, sir, Zn plus 2 concentration. And similar, raised to the power 1. And similarly, if we write this for copper, then it will again be the same. But sir, we know that zinc concentration, once you start the reaction, sir, concentration of zinc will increase, sir. And because concentration of zinc will increase, so that, let's say zinc raised to the power minus 1, so this minus will become plus. So sir, as concentration of zinc will increase, the value of electrode potential of zinc will increase, which is acting as anode. So sir, gradually with time, concentration of Zn plus 2 ion is increasing in the anodic compartment, sir. That means this electrode potential of anode, because this is reduction potential, although at anode oxidation is taking place, but because oxidation is taking place, that means electrode potential of anode will increase with time. And sir, copper is getting, sir, let me write that for you again. Sir, for copper, Cu plus 2 will take 2 electron and will form copper solid. Sir, for this also we'll write electrode potential like this only, as in electrode potential of copper will be standard electrode potential of copper minus 0.059 upon number of electron transferred is 2 into log of 1 upon copper plus 2 concentration. But sir, with time na, we have seen, sir, initially only, sir, copper was getting deposited, so concentration of copper ions in the solution will fall as time will progress. Sir, this will fall, sir. Sir, if it goes as minus 1, so this minus will become plus. Okay, sir. That means as copper ion will decrease, the log value will decrease. That means, sir, this will also decrease. So my point is, my basic graph is, sir, if I start my reaction, then in the beginning, sir, this, sir, concentration of zinc ion, sir, you have not created extra zinc ions. Sir, initially the electrode potential of anode will be 0 and it will be continuously increasing, and then equilibrium will be reached. That means it will become, the electrode potential will become constant. Now, sir, what about reduction potential? We know, sir, this is also, I'm sorry, this is also electrode potential, but this is electrode potential of anode. So let me write that also. This is electrode potential of anode. Acha, not standard one. This is electrode potential of anode, which is increasing. And sir, initially electrode potential of cathode will be highest, sir, and it will be falling, sir. So initially it is highest and it will fall, and then it will attain a constant value, because all the reaction do not reach completion, they reach equilibrium. Sir, that means at this point, sir, which is the time for equilibrium, the electrode potential of cathode is decreasing and the electrode potential of anode is increasing, and after time t, which is equilibrium, electrode potential of cathode and anode will become equal. Sir, what is cell potential? Now, if you apply KVL or KCL, which you will obviously learning in your physics, then as per KVL and KCL, you can definitely say the cell potential is nothing but higher potential. Sir, which is higher potential? Sir, higher potential is cathode minus electrode potential of anode. So cell potential is nothing but cell potential of cathode minus cell potential of anode, because at equilibrium both the potentials will become equal. That means cell will stop functioning, because E cell will become 0. I hope everybody is clear. Chalo, sir, I have test series because I am also Bhilai Vidyapeeth student from Chhattisgarh. Okay, beta Utsav, thank you. All the very best for your test series. Sir, teach GOC, definitely. Satyam, beta, organic. I have started the very first chapter in this series I have taken is of organic only, but yes, I have started with hydrocarbons. What details of hydrocarbons? Which are used for alkyl and halide. So, alkenes and alkanes portion we have read just in the live section of PWJ English. Just go, you'll get loads of benefits, and then definitely I'll be coming with GOC as well. Nice teaching, sir. Thank you, beta. I hope everybody is clear till here. Now, let us quickly move forward. Sir, next is, okay, now, sir, application of Nernst equation. So, let us attempt this JEE Mains question. Now, the question says, now, let us attempt it together. So, you also take out your pen and copy. Now, so for the cell, so the cell reaction is given. Okay, now one more thing you should know, how to represent a cell. Because we have known a cell, so how to represent a cell? So, generally, this is my salt bridge. So we don't specify salt bridge as a diagram. We just make this double dash. This is a salt bridge. Sir, on the left side of salt bridge, what do you have? You have your anodic compartment. On the right side, what do you have? Sir, we have our cathodic compartment. And make sure the terminals of anodic and cathodic compartment should always be a conducting terminals. So just check. Yes, sir, it is a solid, it is conducting. Yes, sir, it is also solid, it is also conducting. Make sure once you write this for a gaseous ion electrode, over there also the terminals of the cathodic and anodic compartment, which are those inert metals, make sure you write them over there. Now, sir, how to write this anodic and cathodic reaction, sir? Copper solid is converting to copper plus 2. Sir, solid is solid state, plus 2 is ion, so you always write single dash, single line whenever there is phase transformation. So solid and aqueous, so separate it with a separator. That will obviously tell you that from 0 it is getting to plus 2. That means that this is the oxidation half, that is anodic half on the left. Now, So silver from +1 oxidation state is getting to 0. So again a separator, which is signifying the phase change, the physical state change. Now, sir, pure solid do not impact state of equilibrium, but sir, concentration of ions do. So concentration of ions or pressure of gases you should always mention in the bracket as mentioned over here. Now this is how you represent a cell. So that means cell is represented and cell potential is also given. Now, for this cell potential is given and you are asked the cell potential of this, sir. So in order to calculate this, concentration of ion is there, but sir, I need E naught cell. Concentration I will use, sir, in Nernst equation, but sir, I need E naught cell, and the same cell it is using above. So from our first equation you can calculate E naught cell. So let us do it. So sir, E1, which is the cell potential, will be standard cell potential, which I want to calculate, which will be electrode potential of cathode, which is silver, minus electrode potential of anode, which is copper. But why write? Because we just need the value of E naught, so why write it completely? Minus 0.059 upon number of electron transferred. Sir, copper is going from 0 to +2, so charge transfer will be 2 here also. You will take 2 of these ions, so number of electron transferred is 2 into log of. Now beta, before writing the value of reaction quotient Q, please write the reaction in order to justify the stoichiometry. Sir, obviously it is easy, but please write it. So copper solid is getting oxidized to form copper +2 aqueous. Definitely it will be oxidation, that means it is giving 2 electrons. And sir, silver plus from solution is taking electron and getting reduced to form silver solid, but sir, charge transfer has to be equal because whatever it is giving, it should take. Sir, it is giving 2 electrons, so that means you have to multiply this complete reaction by 2 and then you have to add, then the electron transfer will be getting equated. That means the reaction becomes left hand side copper solid plus twice of silver ions giving you copper ions plus twice of silver solid. Why I'm specially mentioning solid? Because concentration of pure solid do not impact the state of equilibrium, but iron does. So that means, sir, value of Q will be concentration of copper +2. Let me write Q over here. Q will be concentration of copper +2 raised to the power 1 upon concentration of silver ions, but it has to be squared. But it has to be squared. Now let us quickly put the value. So copper +2 concentration is where? So this is here 10 raised to the power -1. So 10 raised to the power -1 upon Ag plus 10 raised to the power -2, but I have to square it. So -2 squared is -4. So that means this is 10 raised to the power 3. That means this is 3 log 10. So that is nothing but, this value is nothing but 3 into 1. Now you just have to do mathematics because this value is also given. This value is given out to be 0.3095. This is how you will get your value of E naught. So just into divide I'm not doing. Into divide obviously you have to do. That will be your task after this live. So you calculate E naught. Now use that E naught here. How, sir? Because it is now telling us to calculate cell potential. So the cell potential, which I do not know, will be standard cell potential, which will be same. So I can import that value from equation 1. Let's say this is equation 1. Minus 0.059, sir, equation is same, so number of electron transfer will also be same too, into, but sir, concentration they have changed, sir. And sir, Nernst has told us if you change concentration, if you change temperature, potential will change, so it is changing. So let us calculate how much it is changing. Copper +2 is 10 raised to the power -2. So copper +2 is 10 raised to the power -2 upon then silver plus is 10 raised to the power -3, but it has to be squared. So 10 raised to the power -3 squared is -6. That means it will be 10 raised to the power 4. That means it will be 4 log 10. So 4 into 1. E naught value you will directly put from the top. This you can solve easily and you will get your answer. Let me help you with the answer. Into divide is definitely your piece of job. Yes, you will be having 0.28 something. So you have to report in integer into 10 raised to the power -2. So your answer will be 28. So answer will be 0.28 something. Cool? Cool, everybody? Hello? So one doubt. I purchased Laksh batch late and unable to complete backlogs. I focus and watching lectures, making notes, but because of less time, I am able to solve module DPPs test. Please help. Uh, Avijot Singh, beta, actually watching lectures will not help entirely. Why? Because once you watch, maybe you can watch it twice, maybe you can browse through your notes, then for the time being you feel you know things, but you have to reproduce each and everything on the D day of examination of JEE without practicing questions. Yes, you may segregate the questions, like the questions which even I do this, that in my classes I give practice questions with the theory also. So at least do those homework questions, because they will help you to remember and recollect the formulas for longer duration. And then you practice only PYQs. What PYQs? First mains. Rather, leave DPP, leave module for time being. I'm not saying, but yes, that will definitely hamper you for getting extra edge. So if you are anyway moving behind and having backlog, so at least take a rhythm of at least clearing JEE mains first. Then gradually, once momentum is gained, you will rush forward. But yes, you have to be disciplined enough to do this. Okay? Cool. Now, I hope. Hello. Perfect. Now let's start. Sir, I mean, let's continue. What start? We have already started. So this is what I'm talking of. These are the practice questions, direct JEE mains question, which you just see and do applying Nernst equation. So yes, now this is a good one, because this is a conclusion which I feel you should take with you. What is this conclusion? Sir, you have to find out the relation between oxidation potential of hydrogen electrode and pH. Definitely, sir, that means it is talking of hydrogen electrode. Sir, but hydrogen electrode beta standard is 0. If you change concentration, if you change pressure, then it can change. So because I'm talking of oxidation potential of hydrogen, so let me write the oxidation half of the reaction. Sir, so oxidation is 0 to +2. So hydrogen is in 0 state here. It is going to +1 state here. So this is my oxidation half of the reaction. In order to balance, let me write 2 over here. And then 2 electrons will balance charge. So this is oxidation half. And Nernst says that electrode, technically Nernst is used for electrode potential. But if I'm writing oxidation potential, so this will be oxidation potential. So oxidation potential, which is hydrogen forming H plus ion. Now, hydrogen forming H plus, that means 0 to +1. So it is oxidation potential. Oxidation potential according to Nernst will be standard oxidation potential minus 0.059 upon number of electron transferred is 2 into log of. Now, sir, pure solid and pure liquid do not impact, but gaseous and ions do impact equilibrium. So the reaction quotient value will be H plus ion concentration squared upon partial pressure of hydrogen gas, because sometimes they even change this partial pressure of hydrogen gas. But yes, for the time being, they are not giving anything about the gas, and definitely we know this pressure at standard condition is 1 bar. But beta, if the question many times changes this, so if they are changing pressure, correspondingly put that pressure value. Because it is not mentioning, so I'm taking that as 1 bar, so this is removed. Now definitely if this is removed, then this 2 and this 2 will be getting cancelled. So let's say this is my oxidation potential. Obviously standard value is 0, sir, but reduction potential is 0. Then oxidation potential is minus of 0, so that is also be 0. Standard value is 0. But what about next, sir? So 0.059, sir, this 2 and this 2 will be getting cancelled, because log of a raised power b will be b log a. So this 2 and this 2 will be getting cancelled. And minus of log of H plus is nothing but pH. That means, sir, I have a general formula which even I suggest you should remember for advanced level of good questions also, because sometimes this only conclusion will be utilized in much longer derivation. Else you can do this, but these are some conclusions which I feel you should definitely keep in your pocket. Cool. Now, any doubt till here? Now, any doubt till here? So same thing you can apply. The pH of the solution you are asked. if reduction potential is this much. So reduction potential, sir, we know for hydrogen oxidation potential. So it will be, sir, minus of reduction potential. And the formula we have just derived, 0.059 into pH. So we have to find this pH. So this pH will be nothing but negative of reduction potential, and it is giving it, so minus of minus will be plus 0.59 upon 0.059. So this is also mathematically easy. This will be just 10. So pH is 10. So pH is 10. I hope everybody is clear. Now moving forward. Now sir, now technically they use lot of ionic and make your equilibrium chapter a nightmare. But yes, if you are conceptually sound with ionic equilibrium, but yes, I'm not discussing all those ionic equilibrium concepts over here, because definitely it will be taking a lot of time. But yes, a basic ionic I'm just discussing with this one. So please, everybody, please just attempt this. Everybody, I just want you to at least read the question. Just read the question. Just have a reading of the question. Quick. Just have a reading of the question. Quick. Because such questions you are going to get a lot in your examinations. A lot. Chalo. I hope people are attempting it. Now, quick. So the question says, the reduction potential of hydrogen electrode at 298 Kelvin, which is prepared with the help of aqueous solution of acetic acid with concentration this. Sir, now the only problem is this acetic acid, which is CH3COOH, is a weak acid, sir. It will definitely give me CH3COO minus but and H plus, sir, but this H plus will not be the concentration I've taken, sir. This is my concentration C. It will not be this C, sir. This will be C minus C alpha. It will be giving only this small amount of C alpha because, sir, it is a weak acid. So now equilibrium logic will be used. Else, the question was very easy for you. Why? So because you are asking me to calculate reduction potential, and we have recently seen it will be minus 0.059 into pH. But sir, I have to calculate pH of this. And what is pH? Sir, pH is minus of 0.059 into minus of log. That means it is plus. So log of H plus ion concentration. Sir, you need H plus ion concentration. But H plus ion concentration is not C. It is C alpha. Alpha is not given. So you have to do your basic of equilibrium. The dissociation constant of acid is given. Yes, here also pressure is 1, so don't bother about that pressure. Else do that also with basic, because pressure value will be given, will be coming in the denominator, because pressure is also 1, so not bothered. So writing the formula only. Now how to calculate H plus ion concentration? Sir, we know the dissociation constant of the acid K will be C alpha square upon 1 minus alpha. Because acid is weak, so this 1 minus alpha will be 1. That means this alpha will be under root of Ka upon C. Both values are given, K also and C also. What is H plus ion concentration? Sir, H plus ion concentration is C alpha. That means if you put alpha, so it will be under root of Ka into C, and both the values are given. So my H plus ion concentration that you have to put over there will be under root of Ka value, which is 2 into 10 raised to the power minus 5 into C, which is again 10 raised to the power minus 1. So this is 2 raised to the power 1 by 2 into 10 raised to the power minus 6. Why I am writing like this? Because log of this you have to take. So technically this will be 0.059 into log of A into log B, as in log A plus log B. Now I guess this is easy to solve. Why? Because this will be 1 by 2 log 2. So 1 by 2 log 2 will be how much? So this will be 1 by 2 and log 2 is 0.3. Plus, why plus? Because ultimately this will be minus 6 and log 10 is 1. So you just have to solve this and multiply with 0.06. So I guess you will be getting your answer. Let's say I have my answer over here. Yes. Your answer will be 0 minus 0.168. So it will be minus 0.168 volt. So yes, into divide you have to do, and you have to practice such questions in order to master them better. Cool? Perfect? Chalo. Now, again a practice question for you. Now quickly moving to concentration cell. Sir, what are these concentration cells? Beta, concentration cells are those cells once you have E0 cell as 0. Sir, how can E0 cell become 0? Sir, E0 cell as an E0 cathode minus E0 anode. If you take same cathode and anode material, sir, but why current will flow? How potential will be different? Because changing concentration will give you different electrode potential, and hence you can have different potential difference, so you can have those current. So a concentration cell is a cell where E0 cell is 0. Basically you have two types of concentration cell. The first type of concentration cell is termed as a electrolytic concentration cell. Concentration cell I'm writing as CC. So what is an electrolytic concentration cell? Let me give you a brief about it. Sir, what brief? Let us represent a cell rather than making that bulky diagram. So let's say I have zinc solid forming Zn plus 2, but this Zn plus 2 is having concentration C1 in the anodic compartment. Salt bridge. Sir, again I'm having Zn plus 2 ion in the cathodic compartment also, but with concentration C2. And because sir concentration is same, so this potential and this potential will be different. Writing the cell potential will be, sir, E cell is equal to E0 cell. E0 cell will be E0 cathode and E0 anode. Not as in standard condition. So standard condition concentration you will consider 1 molar. So this E0 cathode and anode will be 0. So concentration cell is a cell when E0 cell is 0 minus 0.059 upon, in this case, number of electron transferred will be 2 into log of, because there is no problem of stoichiometry, because this will be just zinc giving one zinc, zinc giving one zinc. So sir, but this zinc solid will be giving Zn plus 2 in the product. So this Zn plus 2 which is at the anode side will come in the numerator. So concentration of C1, that is anodic compartment, will come in the numerator with obviously stoichiometry 1. And this C2 will come in the denominator with obviously beta stoichiometry can change. So first you have to write the reaction, because this is a simple reaction. So I'm writing the simpler form. So I hope this is how you can calculate E cell of an electrolytic cell. I hope everybody is clear. Now, sir, sometimes you can also have electrode concentration cell. How, sir? Very easy, beta. How come you can expect an electrode concentration cell, sir? Beta, you can have that electrode concentration cell. How? So let's say I'm just not making that diagram. I'm just giving you the cell representation, because we know anodic compartment and cathodic compartment. Sir, if I use hydrogen gas, so sir, hydrogen gas as in hydrogen from 0 oxidation state will change to H plus aqueous. This is the anodic half. But sir, hydrogen is passed through platinum solid. So this platinum solid is carrying this hydrogen gas. And sir, for gas, you should write pressure. So let's say this is P1. It is changing to H plus with concentration C1. I'm changing the concentration also. I'm changing the pressure also. Technically, if I'm only talking of electrode concentration cell, then I should take the concentration of H plus ion same. Technically, if I'm talking of electrode concentration cell, so see, I'm changing the concentration. I'm changing the pressure of electrode. So pressure of electrode will change the value of Q. It will change the value. But I'm taking electrode concentration cell also, and I'm coupling this with electrolytic also. So this is both electrode with electrolytic concentration cell, because I'm changing this concentration also. Then what should come, sir? Then, sir, salt bridge will come. Then what compartment, sir? The the cathodic compartment. But beta, in the cathodic compartment, what I have told you, that whatever is happening over here, the terminals should always, who is the terminal of the anodic compartment? Platinum, although inert, but that terminals need to be at the ends. It will create a problem in the anionic electrode for Cl minus. So make sure these terminals are always at the extreme ends. And then even the oxidation half or the reduction half can be represented accurately or not, that doesn't matter. This terminals has to be there in the ends, at the ends. Now, so in order for reduction, H plus ion from the solution, let's say, because I'm taking electrolytic, so concentration C2, phase transformation, because this is aqueous, and I will be getting hydrogen gas. Let's say pressure is P2 along platinum solid. So what will be the reaction, sir? Sir, writing the reaction will be hydrogen gas forming twice of H plus, giving 2 electrons. Then from that side, twice of H plus ions from the solution taking electrons and producing hydrogen gas. But sir, because I have mentioned them with different colors, so this is my anodic compartment with a green color, and this is my cathodic compartment with the pink color. So here, green color is having pressure P1, concentration C1. Pink color, as in cathodic compartment, is having concentration C2 and pressure P2. Obviously, if you add them, now I will not cancel them, because concentration is now only this thing will be getting cancelled. So how can I write cell potential? So applying Nernst equation, I can comfortably say cell potential will be equal to standard cell potential. So E naught of cathode is also 0, anode is also 0, although if they are not 0, still, because it is concentration cell, so E naught cell will be 0, because cathode minus anode will be 0. Minus 0.059 upon number of electron transferred are 2 in this case, into log of, because I'm taking all the variables, so concentration of H plus at the product side is C1 squared, so C1 squared into P2 upon C2 squared into P1. Yes, obviously, generally this P1 and P2 for a mains level of question is 1. So again, you will take C1 upon C2 square. So this 2 and 2 will be getting cancelled, but only when pressure has 1. If pressure is different, then, sir, here pressure will definitely be different, because you are talking of changing the electrode. So how the pressure, sir, only once you change the pressure of electrode, then only the value of Q will change. I hope everybody get that. I hope everybody got that, my dear students. Chalo, great. So we can practice few questions for this. So these are your practice questions which I'm giving. Yes, again, this ionic thing you have to again consider, because this C2 is concentration of COOH. So you will be requiring value of dissociation constant of K of this also. Then only you will be getting that H plus ion concentration, the same logic which I have discussed. The homework and practice question for you. Let us quickly do this. Everybody, please attempt this. Acha, let me give you time for this. Quickly, take 30 seconds, quick, ABCD, quick. Then the best topic for this topic, this is the type of electrodes, the metal insoluble salt. I mean, let me just iterate this for metal insoluble salt and ion electrode. Beta, for metal insoluble salt and ion electrode, the standard electrode potential of metal insoluble salt and ion electrode is equal to standard electrode potential of the metal ion, the exact metal ion, plus RT upon NF into log of KSP of that insoluble salt. That is plus. So that means the standard value is not equal. But yes, irony is this is God's grace that the electrode potential, not the standard one I have given you the formula. The electrode potential of metal insoluble salt anion and the electrode potential of that metal ion are exactly equal. We can prove this also, but yes, we will prove that in the next class, in the next part of of electrochemistry. Abha, Abha FIFA. Sir, I have examined the batch. I have, oh boy, 156 lecture backlog. Yes, Abha, I can definitely feel that it's not, it's huge beta. And obviously that could not have been taken place in a day. So the recovery can also not be expected in a day, Abha. So Abhay FIFA, because you are have written that FIFA, that means FIFA FIFA interests you a lot. But beta, please make sure, don't have this idea. You have to start to work beta, start to work. If the backlog is making you fearful, then definitely you should start with a fresh batch. Join us, Laksh J in English or Arjuna J in English. Obviously if you are class 12, so Laksh will be better. So, but yes, beta, you have to start at some point of time, or else this backlog is not going to vanish in a day because they have not been created in a day. So answer for the question is option 1. I guess poll is not working. So let me give you a brief about it. The question says the electrode concentration cell you have to calculate for this. Okay, sir. Uh, so sir, electrode as in hydrogen gas pressure is P1. Sir, it is taking the same electrolyte. So that means they are not changing the concentration of the electrolyte. And only this is changing. So I hope we have just devised the formula. The formula was E cell is equal to minus 0.059 upon 2. So this concentration is same, so don't bother about this. So it will be P2 as in pressure of the cathodic compartment upon P1. So this will be minus of cathodic upon anodic. So it will be minus of cathodic upon anodic. So this E cell will be equal to minus of 0.059 upon 2 into log of cathodic, which is P2 here also, anodic, which is P1 here also with stoichiometry 1. Now I want this electrode concentration cell to function. So if you want it to be functional, that means you want it to be positive, because if cell potential is positive, then only you can sell that battery in a market. So if you want this to be positive, sir, I already have a negative sign. So this negative sign can become positive. How? When value of log will be negative. Sir, we know this is graph for log x. If this is log x, then this is x and x is 1. So if x is greater than 1, then log x is positive. If x is less than 1, then log is negative. So I want log to be negative because this minus and minus will become positive. That means I want this value to be lesser than 1. So you want P2 by P1 to be lesser than 1. That means you want P1 to be greater in magnitude. So option 1 is your answer. I hope everybody get it. Cool. Moving to beta C. Now such questions, not once, you will be getting so many questions of this form. So I'm just giving you these questions for practice. And then we move to type of electrodes. Cool. And then we move to type of electrodes. Now, type of electrodes, and after that the Kohlrash's law, the conductance, the resistance, the application of Kohlrash's law. This part I'm leaving. Because as I promised, I will not make this session extended. So type of electrodes, but yes, one point I'm definitely mentioning you. The best and the most famous type of electrode is for JEE Mains, also for JEE Advanced. It is metal insoluble salt anion electrode. Why? Because sir, insoluble salt will create very less number of ions, sir. And if it is creating very less number of ions, sir, then you have to make the solution conducting. So we add another anion to make the solution conducting. And let's say the famous one is, let's say I have a bucket, I put water in it. The most famous insoluble salt for us is all the silver salt. So let's say AgCl. But sir, AgCl solid is a sparingly soluble salt. It will be very less ionizing and forming Ag plus and Cl minus ion. How much it can ionize and it can ionize, it can be only decided by the value of solubility product, Ksp value. But sir, because it will give very less number of ions, so sir, how the conduction will take place? Because water is also weak electrolyte, this is also weak electrolyte. So in order to make water conducting, we add chloride ions from some strong electrolyte, let's say NaCl, KCl. So this is an insoluble salt, but technically if I dip silver solid in this insoluble salt anion electrode, then sir, redox, although this is limited, but it will be a saturated solution, so it will be having at least some Ag plus. So that limited amount of Ag plus can definitely have interaction with this Ag, sir. So definitely you can form an electrode. So the electrode potential will be, first let us write the reaction, sir, reduction. So AgCl, sir, why you are writing AgCl? Because sir, it's a solid, it will give very limited number of Ag plus ion, but that limited number of Ag plus ion can take electrons and they can form silver solid. So sir, the reduction half is seen, sir, but this chlorine is not mentioned, sir. This, for balancing also you require chlorine, and for making the solution conducting also you require some large number of ions, and which are provided with this Cl minus. But this Cl minus ion, its concentration will largely be decided by whom? Will be decided by the concentration of the strong electrolyte which are using to create Cl minus ion over here. So this will be your half reaction, the reduction half reaction for this metal insoluble salt anion electrode. And very important conclusion for this is point number 1. So the standard reduction potential as an E0 value of AgCl solid changing to Ag solid using, who is using Cl minus ion? Sir, this this AgCl is using Cl minus ion, because Cl minus ion is in aqueous condition. So let me do phase transformation here also. So using Cl minus ion, this AgCl is forming Ag. This is reduction half. But this is electrode potential, this is standard electrode potential of this metal insoluble salt anion electrode. It will be equal to standard cell potential of Ag plus 2 Ag. So what is this? Beta, this is your simple metal ion electrode. So let's say here I have used Ag plus with a strong electrolyte. Let's say I have dipped silver rod but in AgNO3. Sir, AgNO3 is a complete electrolyte, it will give all the Ag plus, but sir, that will be metal ion electrode. So sir, but this is metal ion. Yes, this is simple metal ion electrode. So sir, both their potentials will not be same. No, their standard potential will, you tell me why it will be same. Sir, it is giving limited number of Ag plus. Sir, AgNO3 will give all Ag plus, so that will be our simple case which we have seen. Zinc, Zn plus 2, copper plus 2, they are simple metal ion electrode. Sir, but this is giving very limited number of Ag plus. So standard potential of insoluble salt electrode is equal to standard potential of the normal metal ion electrode plus Nernst equation is minus, but this is plus what? The same value, RT upon NF. Yes, obviously here the value of N will be 1, here the value of N will be 1, but yes, it can change if you change the metal insoluble salt anion into ln of the value of Ksp, this Ksp. Sir, can you prove it? Definitely I'll prove it, but yes, in the next half of electrochemistry. And second thing is, although their standard potential is not same, but their electrode potential is same. As in, if I just use, if I just use this, then electrode potential of this metal ion electrode is actually exactly equal to electrode potential of the metal ion. Their electrode potentials are exactly equal, but their standard value are not. Sir, how their electrode? Sir, we can write Nernst equation for this also. We can write Nernst equation for this also separately, and we will prove this also. We'll prove this also. We'll prove this also. We'll prove this also. But yes, but beta, this is a very beautiful observation. So after proving this also, I will definitely request each and every one of you to at least keep this in your mind, because this is not used once. This is all the time used by JEE Mains and Advanced. है ना? So this is it. This is it from me. This is Gaurav Singh Arora signing off with part 1 of electrochemistry. And yes, definitely I'll be coming next with part 2 of electrochemistry. But yes, I will be giving you many of the questions for practice, and from where you can download these notes from, just go to PWJ English WhatsApp channel. And in that WhatsApp channel, once this live is done, you will be finding these lecture notes. Please download them, make use of them, make use of the practice questions. This will be electrochemistry 1. I will be coming next week with electrochemistry 2. So bye bye, take care, and I will see you soon. Bye bye.